Let's find something we want to make, some crazy idea. We'll figure out what it takes to make that dream appear. We'll try to understand now as we ride along again. Now hop on the coding train, coding train, coding train. Come along and join us as we light it up in code, using only our imagination as the road. Whatever you're conceiving, you'll start seeing what you're believing. Just hop on the coding train, coding train, coding train. Pick you all up at the station. We'll make things of our own creation. Fireworks, we can generate sounds or trees or mazes. Make a butterfly or reflect our faces. A retro game for a Twitter bot. And never forget that this.dot. Just hop on the coding train, coding train, coding train.
Hello, good afternoon. Hello, happy Friday. It has been a very long time since I've been here live streaming on YouTube. In fact, it has been actually, I don't want to admit this, it's been exactly 3 weeks. 1 week was Thanksgiving. Last week I had strep throat, which I recommend not contracting. I have been told, well, I'm no longer contagious, and that also you cannot get strep throat from watching a live stream. So, assuming that that's all true, I'm here, you are here, we are here together, we will do some coding, and that is that. This is the coding train. My name is Daniel Schiffman, and I appear here most Fridays, and in fact I have some announcements to make, which is that I have now missed 2 Fridays for being sick, actually. One strep throat and one I had this awful other cold thing. And I'm wrapping up a few things at the end of the year. My schedule is a little bit more flexible next week. As of now, I'm scheduled to do 3. 1, 2, 3 live streams next week. And then I will be doing one final year-end live stream right now, tentatively scheduled for Thursday, December 21st. Now, you might be asking, I hope you can all hear me. You might be asking, well, how can I find out about the schedule? And if so, I have a new system, which is really terrible, but it's better than my other non-existent system. And definitely, let's help save net neutrality, which is that the README, oh, computer, come alive. The README here, I try to keep a schedule. So this is, oh, this is wrong. I've got to change. This one is going to be in the afternoon. So this is today, Friday, December 8th. All these times are Eastern time, New York City time. That's my time zone. This is today. These are some things that I'm thinking about doing. Next Tuesday, I will do a live stream in the morning. Next Thursday, I will do one in the afternoon. And next Friday, I will do one in the morning. Then, on Monday, December 18th, I will be roaming out of this room. Oh, I can't switch my camera. Ooh. There we go. Oh, uh-oh. Come with me. Let me try this again. This bad shtick that's not rehearsed. I will be walking this way. Come on. Come with me, everybody. Oh, look. Now, come with me over here. Hey. Oh, gosh. Don't talk to me, otherwise you'll be live on the internet. No, you can. This is some very bad shtick where I open the door. I'll see you later. Oh, there's a hallway out there where people sometimes say hello to me, as you might have just noticed. But on that Monday, I will be leaving this room. You might think that I live in this room. I don't actually live in this room, although New York City is a very expensive place where space is at a premium. I bet you this would go for quite a bit per month in rent if you wanted to live here. But what I was saying is that I'm going to leave this room, go downstairs to the 4th floor with my roving mobile device and live stream the year-end show here at ITP New York University and show you a whole bunch of projects that students have been making all semester. If you don't know what that is, you can probably search on YouTube for Winter Show 2017, Spring Show, Winter Show 2016, Spring Show 2017. Those are some other live streams and videos that I've done. Come on, this way. Oh, wait. Oh my goodness, what's happened here? Sorry, hold on. Wait, hold on. Here we go, okay. Come on, this way. Boy, is that the hype train I hear? I don't know. Okay, so looking at the chat. Morocco, somebody is actually watching this live stream from Morocco. That is amazing to me. Hello to all the international viewers. This is called a tissue, and I'm going to wipe my nose with it. All right, so what's happening today? What other things do I want to announce? A couple things. Holidays are coming up. I feel obligated to do some marketing here. I have a new Amazon page. If you go to amazon.com/shop/coding-train, I think. Nope. The Coding Train? The Coding Train? Yeah, there we go. If you go to amazon.com/shop/thecoding-train, you can see here, this is, you can get your very own. It's not a coding train whistle, but it's a train whistle. So I've just created this page to collect different books and resources that I use in some of the videos. And it's true, if you go to this page and click on one of these links and shop on Amazon, I get some sort of commission from that. So I wanted to mention that that is there and available to you. I also wanted to say that was a loud clap, that it is the year-end fundraiser for the Processing Foundation. You can see here that we have a goal, the Processing Foundation, to raise $20,000 in December. And you can donate now if you want, but my plan is December 21st will be a live telethon experience where I do coding tutorials all day. I don't know if it'll be all day, and hopefully have some guests or different things. And as we watch the donations rise for the nonprofit foundation, the Processing Foundation. I should also mention that briefly that for any of you who are Patreon backers, patreon.com/codingtrain, a couple things. One is I have now sent out every single sticker and book reward to every single sticker to everyone, every book reward to every US address, and the international book rewards are going out as we speak. So those will hopefully all be finished within a couple days. It's just a lot more complicated because I have to fill out all these customs forms. So if anybody has any brilliant ideas for how I can ship books internationally in a more efficient way. So I wanted to mention that. Now I also know, I don't want to belabor this point, but I know there have been some recent changes in the Patreon fee structure, and there's been some controversy associated with that. If anything that, if you are a patron backer and anything about the new Patreon changes is something that you're unhappy about, it's not something I have control over, but I would love to hear from you about that. And if for some reason you cancel your pledge because of that, please let me know. And of course I understand backing anything on Patreon is certainly just an optional thing for people who are capable of doing so. Okay, so, hey Dan, what's you doing today? Asks Lavani and Georgi in the chat. So I have some good and bad news. The good news is, here I am, the coding train is here for you on Friday to do some coding stuff. I do feel like I need to this needs to be finished. So I have holes for beginners. I have a whole set of tutorials right here, which is this playlist. So this playlist is the Beginner Foundations of Programming in JavaScript playlist. As you go through this playlist and you look and you look and you look, you see, suddenly I get older. I'm here talking about functions and return, and I have this youthful glow around me, and I'm making a video that's only 7 minutes. Then you can see parts of my brain. Oh wait, oh no, this is only 2 minutes. My joke was going to be that it's longer, 20 minutes. So then I change. And because what happened is I had a whole bunch of videos about making objects in JavaScript using the constructor function and all about prototypes and that sort of thing. And I am changing over Today, this year, 2017 and 2018 will be the year of ES6 for me. And so I've been slowly replacing these videos. So 6.2 got replaced. 6.3 got replaced. Whoa, whoa, ah! Oh my God, I'm hearing some sort of horrible ad. Where's... No, wait. Can you guys hear that? What is this? No, stop. Where's that playing? How come I can't see it? Okay, it's come back to me. I was really trying to do some sort of dramatic something that totally failed. Okay, here we go. Wait. Yeah, that's been replaced with classes. What is an array? That's just about an array. Arrays and loops. Arrays of objects. Yeah, I look old. I think I'm old in this one with a different, yes. And then mouse interaction with objects. I'm wearing a coding train t-shirt. That's a good sign. That's been replaced. Removing objects from arrays. That's been replaced. Checking objects intersection, no. And objects and images, no. So I feel like I should do these last three. So today I'm going to do that. Just to have that done, it's out of the way, it's finished. This series is complete for all of you who want to spend your winter holiday break learning to program in JavaScript. You won't be confused by the different styles of doing object-oriented programming in JavaScript in this video. Okay. So that's what I'm going to start with. What else might I do today? I've had a lot of requests to use WebGL. Have I? Or did I just make that up? People ask about it. I wanted to see if I had some time to revisit WebGL rendering in P5.js. I am so excited. I have recently learned about these JavaScript array functions like map and fill and reduce, and I use them all the time, and I use them all the time with that arrow syntax, and I actually really like it. So I want to bring that joy of these array functions with the arrow syntax to you, because in the future I want to do a lot of stuff around working with data, vector data, clustering, some machine learning topics, and having some of these concepts of array functions will be really helpful. And this I'm kind of unsure about, but it's been asked so many times. It gets requested a lot. Let's actually take a look here. Let's go to Rainbow Topics. So if you're wondering, this is a place where you can submit ideas or questions. It's a place where they go to ideas and questions go to die because I never get to any of them. But in theory, it's a place where I can kind of organize ideas for future streams, and someday I'll catch up to all of these things. But what you can also do here on this is I can sort it by most reactions, most thumbs up reactions, and let's see. All right, this is coming. Chrome extensions. I did them. That could be closed. That issue could be closed, and links to the videos can be there. So there's a bunch of things somewhere in here. Boy, it's not very high up. This one, here we go. Conway's Game of Life. It had six thumbs up. But I get this in YouTube comments a lot. People are really interested in me doing a coding challenge to implement this. I do have some tutorials where I do it, where I talk about it and I show some examples, but I never actually sort of programmed it from scratch. So that's something I'm thinking of doing today as a challenge. And if you have any ideas for really simple 3D things I could do as a P5.js WebGL challenge, I would love to hear about them. Maybe you can put them in the comments, and any Patreon backers who are in the YouTube chat, if you catch some good ones, you could paste it into our Slack channel. I do look at the YouTube chat, but it tends to scroll by pretty fast. I miss most things about it. Okay, right, so Luke is asking, didn't you do Game of Life a while ago? And I don't know, I have a video, if I search on YouTube, let's just look, Game of Life. So, okay, first of all, we're getting everything about the Game of Life, that game thing. So that's not going to do us any good. Conway. So, ooh, oh, there I am. 7.3, the Game of Life and Nature of Code, 2 years ago, 28K views. So this is kind of a video. Oh, look at that. That's new. I hover over and it starts to preview me. Oh, it stopped. This video, I explain the Game of Life and I talk about it and then I show my code example, but I don't actually build all of the code for it. And what I'm discovering is there is an audience who really prefers the videos where I just kind of start with a blank file and just code the whole thing while I explain it, as opposed to kind of a more like lecture tutorial thing where I point and talk and demonstrate things. Okay, so that, oh, whoa. Conway's Game of Life 3D in Minecraft. Okay, this might be something I have to do at some point. Okay, so that's that. One other thing I wanted to mention, YouTube Shiftman. I have this new community tab. So this community tab is something that is now on YouTube apparently, and you can see like, oh, I posted something about the Amazon shop. Oh right, I actually wasn't sure which one of these I should do if I have time for just one, so I can do polls here. What happens if I vote for here? Oh boy, this is very confusing. Oh wait, no. Ah, whatever. No, go back. This is my fake account for being live streaming. Of course it knows, and I don't know what the password is. I think I got it. So if I vote, oh boy, this is really, I had to create a channel. All right, never mind. Maybe this is a hassle. Maybe the straw poll thing is better. But anyway, I can't see the results here unless I'm signed in as myself, and I'm petrified of signing into myself while I'm live streaming in case I reveal some kind of YouTube something or other by accident. All right. Anyway, so that community tab is there. I'm going to try to, mostly I use GitHub. The tools that I use associated with this channel are GitHub for all of the code and lists that I'm making, YouTube for publishing the videos, and now this community tab, Twitter for kind of making announcements, and maybe Patreon for some crowdfunding, and Slack as a private Slack channel as a benefit to Patreon backers. Okay. 3D Game of Life. Oh, interesting. What did it... I don't know why I couldn't see that as obvious. So maybe let's try that. All right. Let's see here. Now what I need to do is I need to put my little green piece of paper on this laptop. I'm going to go over here. Oop. Thank you, Ada. I believe that suggestion came from Ada, 3D Game of Life. So that seems like a perfect thing to do, and also a reason to do it in P5.js. I'm looking for something. Oh yes, green paper. Now I've got my train conductor hat on as well. All right. So I'm feeling a little bit more settled today. This is my list. I'm going to try to do all those object-oriented programming and JavaScript videos that I feel like I just need to get out of the way. I'm going to maybe talk about some ES6. I don't know if are these actually ES6 with some advanced array functionality. I'm maybe going to look at WebGL, and maybe I will code the Game of Life in two-dimensional canvas and then in WebGL. I'm looking at the chat. All right. Oh, I just got very tired all of a sudden. All right. Maybe we need... All right, so let's come back here to... So let me look at these videos here for a second. So where did I last leave off? Removing objects from arrays. So this was what I did. And if I go to the end of this video, what happens at the end? And it does. Still the same exact result. I can delete, I can hover over and delete all of it. So if I click on, great. So if I click on, it deletes the things. So okay, all right. So the next aspect of this that I'm going to look at is, so let's find that example. Where are those examples where I left off? Where did I put them? What's in here? All right, I might actually just have to go and grab the code from, let's see, grab the code from this actual GitHub repository. Actually, hold on. I already have that downloaded here. And where am I going to? P5.js, P5.js. What video is that I'm looking at? What was it? Oh, why does this go to sleep? Don't go to sleep. Boy, one of these days I'm going to prepare before I do a live stream. I already. I'll just guess. No, 9. Maybe it's 8 is arrays. Oh, that's DOM. 7 is arrays. Yes. Removing objects from arrays, 7.5. So in this is where I last left off with this bubble class. There we go. So I will come and bring, let's go grab 7. Let's put it on the desktop. And I'm starting to think that I should use Visual Studio. So many people just love Visual Studio, and I'm kind of seeing people using it, and it looks so fancy and nice. I really like Atom. I don't know, somehow I think I had this reaction of like, oh, it's Microsoft Visual Studio, and that old thing that I used to program in C++ was like this like horrifying, traumatic experience, but this new Microsoft open source Visual Studio is apparently super nice. But I'm going to stick with Atom right now because it's what I'm used to, and I have all my settings there. So let's open this up in Atom. And let me run a nice little server. Where am I going? 07. Let me run a server. And let me go to the browser. So this should be, whoa. This should be, can I move this over here? Yes, this should be the last. Whoa, I got some Chrome extensions still activated. Let's turn those off. I can just get rid of them. And let's go here. Now what's going on in this example? Mouse dragged, got it? This is where I last left off. Okay, right, this was the end of that last video. This was the last example that I did in that tutorial series. Let's get rid of the reference to the sound library so that we don't get this unnecessary error message here. And there we go. All right. I am just about ready. So, what I'm going to do is I am now also going to test and see how this looks. Oh, that's not a good sign. Randy would be telling me right now I reminded you to check your markers. Oh, that's better. Not great. That's pretty good. Can you see it? That's the question. I'm going to walk over here to look. Focus looks good. I think we're good. I already forgot which one that was. This one. So this is my marker for today. Putting it right over here. And I am now going to just clean the whiteboard a little bit. And play you some music. As always, I always forget the this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget to this dot, this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget to this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. All right. Now, I also just remembered that I have a time limit here, and I might as well plug this for a little bit if anybody, let's see, if I go to itp.nyu.edu big screens, will that give me the information? Yes, this is tonight. Doors open at 6 p.m., Friday, December 8th, 555 West 18th Street. I guess you had to RSVP. You have to travel back in time to RSVP. But I will be there at this event tonight. I will try to remember before I go to shove a whole bunch of Coding Train stickers in my jacket pocket. So if you're there, if you're coming to this event for any reason, please say hello to me and ask me for a sticker if you would like a sticker. I don't actually just offer people stickers because that seems weird. Like I'm kind of like a creepy sticker offering, like, hey, would you like my Coding Train sticker? But I'm really excited if somebody asks me. And then I'm also like really disappointed and upset with myself if somebody asks me and I don't have them on me. But anyway, stickers aside. All right, so that I wanted to mention. So I do have to be out of here by 5 at least to make it over there and to watch all the wonderful work. The other thing, so okay. Why am I not signed into GitHub? I guess I'm not gonna worry about that. So now what I'm going to do is, so interesting enough, I'm just curious what I did in the tutorial from quite a while ago. All right, okay. So that's what I did. And then here, yeah, okay. So I'm not too worried about this. And then this one, whoa, weird. I don't remember making this page, and it's also not working, but I'll come back to that. Okay. So here we go. It is time for more bubbles. So the topic of this video is, and here's what I'm gonna actually do some pre-video coding because so what I'm going to do is actually set myself up with an example where I create 2 bubbles, and then I am going to bubble 1, bubble 2, and I'm going to, actually this will be useful, the change brightness thing, that'll be useful, I'll keep that. The contained thing, I'm going to leave that. So, and the move, and the show. So if I run this, What's wrong here? Bubble 1, bubble 2. Oh, I didn't give it a size. So let's try that. Move, show, what's wrong here? Oh, bubble 1, move and show, and bubble 2, move and show. There we go. All right, so I have these two bubbles moving. Now the other thing, by the way, I've noticed, right, this is correct, right? If I say r equals 100, and r equals 50, and I take these out, right? They get that size, but if I do this, is this an ES6 thing? Or has that always been true in JavaScript? Is this overloading of a method or giving default values to a, because I've always done the thing like I check to see if the argument was passed in, and then I assign it a value if it wasn't. But it looks like here I can give it a default value just here. So, so what I'm looking for, what I'm curious is, the defaults are new. That's part of ES6. Okay. So, all right. So, maybe I'll sneak that into this video for no good reason. I'm gonna do something. You guys who are the live viewers will witness something very special because I'm going to pretend to accidentally have this problem, and then I'm going to solve it. This is going to be a staged fake bug. I've never done that before. No. I always legitimately make my mistakes and don't pretend to make the mistakes and then correct them later. All right. Okay. So here we go. Oh. Okay. All right. And that overloading you can do with all functions, right? It's not just something that's available as part of a constructor function, right? If I were to say function test x equals 100, and then I just say console.log x, and I refresh this page, and I say test. Oh, maybe I can't. Can I only do this for constructor functions? Hold on. Really? Oh no, I just typed in something wrong. Yeah. Okay, so this works for all functions. Okay. Of course it does. Of course it does. All right. I wrote text. Thank you very much. Hello. Are you just sitting at home wondering, when could I possibly watch another video about bubbles? Well, today's your lucky day. This is another video about bubbles. And in this video, if I could come over here for a second, what I want to look at specifically, And in this video, what I want to look at specifically is how can I, if I have a bubble object like this, bubble 1, and I have another bubble object like this, bubble 2, how can these objects talk to each other, communicate to each other? How can they ask each other questions like, am I intersecting you? Or am I overlapping you? How close are you from me? These types of things. And you can imagine all of the implications and possibilities of this. Now, on the one hand, to do this, all we need to do is figure out some math, right? And that math is, what is the math of two circles that are overlapping versus two circles that aren't overlapping? That math is quite simple in some ways. I just want to look at the distance between the centers of both of those circles, right? And you can see here that that distance is going to tell us whether they're overlapping or not, right? So one way that I could think about it, look at this. If this is R1 and this is R2, right? This is the radius of this circle. This is the radius of this circle. If this distance, right, that's also, this is R2 right here. and this is R1 right here, if that distance is greater than R1 plus R2, then certainly the circles are not overlapping. However, if that distance is less than the sum of the radii of these two circles, then they are overlapping. So on the one hand, this is all I need to do. I need to be able to say, give me the distance, can you see that? Just barely on the top, of between x1, y1, x2, y2, and then I need some sort of if statement to see, is this distance less than R1 plus R2, then they are intersecting. So let's actually go and start to implement that math in the code first. But what I want you to think about is there a way for the objects themselves to handle the computation of that math rather than that math just be fiddling about in the code somewhere perhaps less convenient? So come back over here with me, and let's go over here. And so I have I'm continuing from where I left off. This is essentially the same bubble class that's been in my previous videos. And I'm just going to make two objects. I'm going to say bubble 1 and bubble 2. The E key on my keyboard doesn't work. It only works about 40% of the time, if you notice me pressing it a bunch of times. So then what I'm going to do is I'm going to say bubble 1 equals a new bubble at 200. I'm going to put one on the left side of the screen and one on the 300, 200 on the right side of the screen. Then I'm going to say bubble 1.show and bubble 2.show. So now I should see, and that's bubble 1 and bubble 2. So now, when I go to my sketch, I should hit refresh. I don't see any bubbles. Let's look here. Bubble 1. Oh, look at this. I forgot. The bubble has a R property for its radius, and I did not define that. Here's an interesting thing. As if I'm just coming up with this right now. One of the features of ES6, which is the version of JavaScript that we're using that allows us to write classes to make objects from, allows us to give a default value to a particular argument if we forget to pass it in. So this parameter here, R, which is going to be assigned to the bubble object's R property, I can actually say R equals 50 right up here. And then if I refresh it, look, I have two bubble objects. It's even sort of a weird, oh, I meant for this one to be at 400, not that that really matters. So you can see those are two bubble objects. And I could optionally give one of them if I don't want to use that default value for R, I could give it a value. So this is actually incredibly convenient little piece of syntax here that if you're going to have a parameter to a function, and this is not just for the constructor, you can do this for any function, although it's quite convenient to do it with constructor functions, and I want to give it a default value. So it's a little tidbit there for you inside this video, which is about the objects intersecting. Okay, so now let's move them around. Bubble 1.move, bubble 2.move. Let's move them around just to see. Okay, so what I want, come on bubbles. So we're gonna have to do some work here to get them to, those bubbles to get a little closer to each other. Hold on, timeout. This chat is going, okay. People sometimes in the Slack channel, people are just chatting about stuff, and I see all this activity out of the corner of my eye, and I think, oh my God, I'm doing something horribly wrong. But I'm just going to keep going. Yeah, we're going to get to arrays and a bubble system and all that stuff, but this is the very, very beginning. Where was I? All right, so what I want to do now is I want to go back and you can't really, I did end up going above, but this is fine. You can see that. I'll be better about this in the future. So I want to try to implement this math. For example, what if I want to say, right here in draw, I can say, all right, I need to find the distance between bubble 1.x, bubble 1.y, right? These are the properties, the x and y of that bubble, and bubble 2.x and bubble 2.y. And then and let's just say D. And then I want to say if D is less than what? If it's less, if it's less than bubble 1.r plus bubble 2.r, then, and let's put I'm going to do something silly here. let's put all this over here, and I can say bubble 1 dot, no, I'm just going to say like background 200, 0, 100. Okay? So this is the idea of like, now I have the math for intersection. I know I need to find the distance between those two bubble objects. What's the distance between these two bubble objects? If it's less than the sum of their two radii, then it's intersecting. Okay, so let's run this. You can do it, bubble. Be together, bubbles. Be together. Okay, I'm just gonna have to force it. Let's bring them a little bit closer. There you go. Now move apart, bubbles. So one thing I could do is I could just assign, this is a terrible idea. I could just assign like the bubble location to the mouse or something, and then I could move it and you would be able to see. But the bubbles, they're going to move apart eventually. Come on, move apart. Move apart. Oh, it's so close. I think you saw the background. Okay, so you get that this works, and there we go. I got to be a little bit more thoughtful about the sort of intersection thing. Now, here's the thing. I don't like this at all. I don't like this one bit, because the idea here is eventually, what if I have 3 bubbles, or 4 bubbles, or 10 bubbles, or 100 bubbles? I need some way that I really just want to say, let me see where I have room here. If any arbitrary bubble, B1, I'm going to redo this because I'm just in gross danger. I don't know why I insist on like drawing so high up. If any given bubble, let's say B1, dot intersects B2, I want to be able to write code like this. I want to be able to encapsulate all the idea of this math into a function in the bubble object. So bubbles know how to communicate with each other, how to test one bubble's location versus another bubble's location. So if I come back over here, what I mean is I want to say something like, if bubble 1 dot intersects bubble 2, then do this. Okay? So this is the idea, because then I could start having arrays of things and loops and check every bubble. And it's just going to be more convenient than having this math sort of out here where it doesn't really need to be. So let's take a look at how we might do this. So what this means to me is I need to write a new function that's part of the bubble class called intersects. So that's pretty easy. I could just do that. Done. That function, by the way, because of the way that I wrote it here inside this if statement, the idea is that function is going to return true or return false. So right now, just to have this do something, I could just say return true right here. And the idea here is that, okay, well, the intersects function is a function that's called on one bubble and receives as an argument another bubble. So I need to give it an argument here, and I can call that other, for example. So now, if I comment out this math, and I run this, right, it looks like it's working, but of course, if I move their locations away, it's always drawing that pinkish background because my function always returns true. So one thing you can kind of see from this is it's often worth kind of writing the skeleton of your code and then just like hard coding in true or false and see if it's working as, false, I don't see it. True, I do see it. Now I could actually go and fill in the math in that part. So what I'm going to do is I'm going to grab this math that I had before, and I'm going to bring it down here, and things are going to get a little bit easier. I still want to calculate the distance, but what do I want to calculate it between? I want to calculate it between the bubble that I am right now. What is the bubble that I am right now? This bubble with what? The other bubble that you have so generously passed in as an argument to my parameter named other. Other. And then if that distance is less than my radius and the other radius, then and only then would I return true. And don't worry, I'm going to show you something that's going to make this nicer in a minute, because many of you are complaining right now the way I'm writing this. And we can see now this bubble class has a function called intersects, which can receive any other bubble and always check if the current bubble is intersecting the other bubble. So here we go. I'm going to do this. They're not intersect. Let's hack something to make our life a little easier. Instead of moving bubble 2, I'm just going to say bubble 2.x equals mouse x, and bubble 2.y equals mouse y. Okay, now of course I could write a function to follow the mouse or set the mouse, but I'm just going to throw this in there really quickly so that I can do this, and I can woo, intersects, doesn't intersect. Okay, so now let's take a look at one thing which I want to change here, which is that I am a weird, strange person, and I really like the way I wrote this. It just says it all. I know I have an if statement, and I know when it's true, I want to return true, and when it's false, I want to return false, and I've said all that, and I said it in like 5 lines of code here. But the truth of the matter is, this is a statement, distance is less than this.r plus other.r. That whole statement evaluates to true or false. When it evaluates to true, I want to return true. When it evaluates to false, I want to return false. So this can actually be condensed into just, whoops, oh, autofill, return the result of this Boolean, right? I could just say, is that return the truth of this statement, true or false? And this will, in fact, be the same exact result. Yay! Oh, this is the end of this video. So what have I done here? What might you want to do? Now here's the thing. Let me show you one other thing. Let's ask a question. I'm going to ask a very important question here. If I were to say, if bubble 2 intersects bubble 1, have I changed anything? Program still works. This is exactly the same program. So in this case, I am writing sort of a function. You could maybe make the argument that you want like a bubble manager class, and the bubble manager class has an intersects function that takes 2 bubbles, and so the point is there's always other ways to organize your code, and you have to watch out for like over-engineering your system. But this is one way of doing it. It's a way that I kind of like to do it. Later you might see in other videos or tutorials that I make where I have, instead of just all bubbles, I have frogs and turtles and fish and kitty cats, and maybe the frogs have to check their location relative to the kitty cats, but the kitty cats have to check their location relative to the turtles. So having the different objects act on different kinds of objects is also something that comes up. But what I'm going to do in the next video is, how do I go from this idea to suddenly having a system of like 100 bubbles, and I'm checking if every single one is intersecting any other one, and what happens when we do that. So I am going to do that in the next video. You might actually just give that a try yourself, and then see how it goes and watch the next video. Okay, thanks for watching. I think it would be good to put an annotation with what you wrote. Simon, I'm not sure what that's referring to. I'm looking at the chat. Are we doing the game of life today? I hope so, yes. All right. So I think I'm ready to move on. I'm going to just give myself a second to see if anybody has any questions they want to ask. This is moving. I think I can be done with the next 2 videos by 4 o'clock. I still have a little bit of a cold. Game of life on a Taurus. Whoa, that sounds cool. That could be fun. All right. All right. I'm looking at the chat. I do read the YouTube chat now, Lenoid, and that's what I'm doing right now. I usually can't follow all of it. And I also have, when you say annotation, Simon, do you mean, you must mean, do you mean code comment? Which is, but anyway. Sorry, I forgot the question I was in. I have two chats going on. I try to follow the Slack one because it's a smaller group for Patreon backers, but I also do look at the YouTube one. Do I get burned out? Yes. All right, so here we go. So I think I'm just ready to move on and keep going. Oh, annotation in the video. What did I do something wrong? I still don't understand what I did wrong. Did I make a mistake in this video? I'm not sure. All right. I see Simon Tiger is typing. No, I wrote off the screen. I know, but it's not so bad. You know, you can mostly still see this, right? It's just a little bit cut off. How bad could it be? I'm the worst. I just do that constantly. This huge area to write within, and I can see over there on a monitor where I'm writing, and yet somehow I do that anyway. Okay. All right. Okay, so maybe you watched the previous video, maybe you didn't, I don't know. You're here right now, I'm here right now. I'm going to erase this, I think, because what I want to do right now is look at, wait a second, what was in the previous video might be kind of relevant here. So, what was in the previous video is this idea of how do I have two bubble objects communicate with each other? How do I know if they're, say, intersecting or not? And that could obviously be more than just the sort of like overlappingness of the object. Let me just start over. Because why not? I'm erasing over here. Sorry, I know you guys can't see me. Okay. Hello, it is a bubble. This, in my previous video, which you may or may not have watched, I looked at how I could test if these two circles are overlapping. It's not just about the math to look at if circles are overlapping. While that's interesting, of course, the whole point of this was really to look at an object-oriented sort of technique for how I might write code that just checks if any bubble intersects any other bubble. So I could say if bubble 1 intersects bubble 2, and if I had bubble 4 and bubble 3, or bubble cat, bubble dog, so many possibilities. But what I want to look at in this video is, what if instead of two separate variables, I have an array of bubbles. Maybe there are many of them, some of which are overlapping, some of which are not. How do I check? How do I check if, let's say I call this bubble bubble A, B, C, D, E, F, G, H, I, J, K, L. I just had to go through them all. This bubble A, I have to check, is bubble A intersecting B, C, D, E, F, G, is bubble B, I have to check if bubble B is intersecting any of them. How do I check if every bubble is intersecting every other bubble? Okay, let's look at that. All right, so what I'm going to do first is I'm just going to change this program to have an array of bubbles. Then what I'm going to do is I'm going to create maybe just 10 bubbles to start with. Bubbles index I equals a new bubble, and I'm going to give them random locations and maybe a random size, and I'm going to have them kind of small-ish. And then I'm going to make those bubble objects. I'm going to comment this out here, and I'm now going to say, I'm going to look at, I don't know if I should do this in this video. Oh, I got to do this in a separate video. I'm going to make a separate video, which you can go back and look at. But there is a way, a new way. So, this is a bad idea, but I'm going through it anyway. Right? Normally, I would write this code. And I would just say bubbles index I. Thinking about this. It's fine. My videos are a mess. It's fine that they're always a mess. Show bubbles I move. So let's run this right now. I'm going to get rid of this. Boom. So there we have all of my bubbles moving, showing and moving, showing and moving. I just want to say, and I will make another video about this specifically, that I've been using this new loop that's also part of ES6 version of JavaScript where I could just say for B of bubbles, b.show, b.move. So these are exactly the same thing. Let's just I'm going to do this in a separate video, but while we're here, while you're here with me, and maybe you don't want to click and watch it. This is this idea that I can, I want to iterate over every element of the array, and every element of the array can be addressed by its index, which is typically why I might have a counter like I to count through all the index values, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But it's such a common operation to do something to every element of an array. And in fact, there are lots of other ways that I'm going to show you later that you can even do more with this, that I can just make a variable b called b, this can be anything, cat of bubbles. The point is, this is every this is saying for every element in bubbles, put that element in this variable and then do some stuff and then go do the next one. So you can see it's the same program. The reason why I don't always use this is sometimes I want to only look at certain parts of the array. I need the index value. Sometimes I need to move things around in the array, delete them. But in this case, this is going to make our life a little bit easier. So I'm going to go with it. I'm going with it. Going with it. Whew, okay, where am I? Still in this video. So here we go. Now, I have all of those bubbles. How do I know to check if each one is intersecting every other one? Now, here's the thing. Let's think about this. Let's pretend for a second that there's just one important bubble, which is a separate bubble. So I'm going to say something like, let, what to call it? Kitty. No? Puppy? Unicorn? Rainbow. Unicorn. There is a unicorn bubble. And I'm going to put it in the center of the window. And I'm actually going to do a silly thing where I allow myself to just control it with the mouse. Let's make sure this works, right? Ooh, where'd that? Oh, and I've got to also, what am I doing here? Lost my mind, but I've got to show and move. There's a point to what I'm doing. It's going to make sense in a minute. Stay with me here. So you can see, look at this. Look at this bubble that I'm moving around. There's one separate bubble that's outside of the array that I happen to be giving the mouse location. So what if I want to check if this bubble is intersecting any other bubble? Let's take a look at that. So I'm going to do this. If unicorn.intersects B, this is now saying, hey, I want this special bubble unicorn to check if it's intersecting anything in that array. Anything in that array. I just knocked this camera. Okay? Then, if so, and by the way, what's convenient here is I have this, I already have this function change color, which I used in a previous video. So I can repurpose that function change color to, if it's intersecting that bubble, to change its color. So let's change its color to 100. Otherwise, change its color back to 0. So what I'm doing is I'm saying if the unicorn intersects the bubble, it's got a different brightness than if it does not intersect that particular bubble. And look, you can see, I guess I should make that brightness a little bit higher. So you can see here, right? There we go. So you can see this is working, but this is different than me checking all of these bubbles against each other. How am I going to do that? So what I need to do is, I actually don't want anything to do with this unicorn. So let's comment this unicorn out. But the unicorn served a purpose because it shows us right here that this is what I want to do. For every B in bubbles, show it, move it, and then check if it intersects. And really a different way to write this that would have made more sense is this. And what I want to do is say, don't check just that unicorn, check every other B, every other bubble. So what if I had another loop in here? Right? There's another loop. Just look at this for a second, right? For every bubble, show it and move it, then go through all the bubbles again and check if that bubble is intersecting any of the other ones. Whew. It's tricky. I feel like I need to just pause and breathe for a second. But this is new to you. This is this idea of a nested loop. And I feel like I want to go over to the diagram, and I want to try to redo that diagram for a second. I think I've lost which pen was the good one. Time out for a second. Start this diagram over again. Reuse these paper towels more. Ah! Let me find the good marker. Which one was it? Is it this one over here? Yeah. Okay. Or is it this one? Ooh, this one. Both of these are pretty bad, actually, but I'm going to keep the second one. Let's try this again. I'm just going to have 4 bubbles. A, B, C, and D. I want to check, is A intersecting B, C, or D? Is B intersecting A, C, or D? Is C intersecting A, B, or D? And is D intersecting A, B, or C? Here's the thing, though. Even though this is what I want to check, I just sort of intuitively did something here, which is what I said is I don't want to check if A is intersecting A. But really what I want to do, code-wise, is I want to do this. I want to have A check all 4, then B check all 4, then C check all 4, then D check all 4. But I want to make sure I ignore when it's checking against itself. And then, of course, we could optimize this even further, which maybe I'll do at the end of this video, right? If A is checking B, C, and D, B doesn't really need to check A again. But that's only for this particular case. There could be other instances where we want to check A versus B and B versus A, and that means something different. So let's come back over here and see what I mean here. So first of all, I want to make sure that B does not equal other. So what I want to do is okay, I want to check if B is intersecting every other bubble, as long as B isn't checking itself. So the problem is this actually isn't going to work. It's sort of going to work, but not going to work. And I'll explain to you why. The logic here is quite sound in terms of the 2 loops, but the change color is a bit of a problem. So let's run this and see, I'm not seeing anything change color. Why not? Well, let me do something here. Let's comment out this part. So what I want is I'm only going to change color. I'm never going to change back. So you can see what's going to happen now is any 2 bubbles that intersect each other. Come on, bubbles, you can do it. Ah, there we go. They change color. But as they separate, they stay. So this is an added layer of complexity that I probably should have anticipated when I started making this video. And in a way I could stop here and there might be, but since we're doing this, I think we've got to solve this problem. I'm here, you're here, you could go on and do something else. If you want to solve this problem, how can I now have them turn off when they are not intersecting? So here's the thing. What I want to do is I need to decide, I can't decide whether I want to change the color to black or white right in here. And why is that? Oops. And why is that? The reason is, let's consider this case where A and C are overlapping. And that loop, what it's doing is it's saying, is A intersecting, is A intersecting A? Well, no, don't change the color because they're equal. Is A intersecting B? Well, no, don't change the color because they're not intersecting. Is A intersecting C? Oh, yeah, change the color. Change the color, they're intersecting. Yay, change the color. Okay, oh wait, we're not finished yet. Is A intersecting D? No, no, they're not. Change it back to black. Right, because that else doesn't know that the previous one was intersecting. So this is an issue, right? So because I'm looping through with an else here, unless it's the last one I happen to check, the last one's going to change it back to black. So what I actually need to do is do this kind of trick, and I'm sure there's a more elegant way of doing this. But just for right now, I can say, I'm going to just say, let overlapping equals false. So I'm going to assume it's not overlapping anything. I'm going to assume it's not overlapping anything. Then I'm going to check all of them. And if it's overlapping at least one, I'm going to say true. What's fun about this is I could actually, like, the more it's overlapping, I could add up a number or something. I'm going to check if it's overlapping at least one, set overlapping equal to true. Once I'm done checking everything, now, if I do get overlapping, then I can say b.change color to 55, otherwise b.change color 0. So this is a little bit of a goofy piece of logic that's associated just with this particular scenario, but it's still, the core idea here is that I have this nested loop. I want to check this bubble, every other bubble. Okay, so let's run this again, and you can see it. Let me make the bubbles, let me make more of them. Let's make 20 of them. And you can see that if it's intersecting any other one, it's lighting up. If it's not, it's not lighting up. So this is complete. There are some things here to change. And I'm going to just talk them through for a second, and then I'll decide if I'm going to implement them. So one is there a way, maybe it would make more sense for me to somehow, I think it would make more sense for me, I kind of want to do this, for me to put this overlapping variable inside the bubble object itself. Why can't it keep track of that? And it could keep track of that, and based on it, it could just call the show function with the appropriate, the show function itself could set its color, potentially. So that way I get rid of all this extra gobbledygook code over here, and I'm left still just with the b.intersects other. So that's one thing I could do. The other thing that would be interesting to try is to see if I could reduce the amount of checks, right? By just checking A versus B, C, D, and then just B versus C and D, C just versus D. That's actually all I need. And that could actually be, it doesn't really matter in this case, but I really should finish this video. But so those are two things. Okay, this camera went off. Those are two things. Now, hold on, I forgot what I was thinking. Those are two things. Oh yeah, those are two things. One of those things, probably what I would really want to do and need to do is go back to having the index. So as an exercise that you might like to try is rewrite this code with an I counter and a J counter. What you'll notice is you can start the J with that. Man, I'll do that. Try this. write a lot of comments that I should make another video to solve this, and maybe I will. But so that would be interesting to look at, right? You need to go get the counter because you can start, if I is for all of the bubbles I'm checking, I can start J wherever I left off. The other thing that's kind of an issue here is the following. Let's make these bubbles really small, and let's add 200 of them. That looks like it's working. Let's add 2,000 of them. Okay, it cannot even come close. Let's add 1,000 of them. Let's just go back to that. That was too extreme. So you can see how slow this is. Now, you might be thinking, oh, it's just slow to draw 1,000 things, which is true, but let me show you something here. What if I take out this whole thing about intersection? It's got no problem animating 1,000 bubbles. The problem is, in this algorithm, if I have to check every bubble against every other bubble, if there are 3 bubbles, that's 9 checks. If there are 10 bubbles, that's 100 cycles, 100 checks. If there are 100 bubbles, that's 10,000. I'm just doing my math there for a second. Look, this went up by a factor of 10, but this went up by a factor of 100. And with 1,000 bubbles, suddenly I have to do 1 million checks. So there are ways around this, and there are algorithms for binning, or they have fancy names and quad trees, and someday I'll have a link in this video description to some tutorials where I go over how to make this stuff more efficient. But one of the things you really got to watch out for is this: every object check every other object is an n squared problem. As the number of bubbles increases, the number of computation cycles increases by the number of bubbles squared. So, so this is something you really do have to watch out for. This can get quite slow. And again, someday in this video's description, maybe I'll have a link to something which shows that more efficiently. All right, I'm going to stop. I'm going to stop at the end of this video. And if some of these little tidbits and things are kind of interesting and important, I will do them in a follow-up video. Okay. Goodbye. All right. My screen went off over here because I don't have I need 2 power things. Ugh. Okay. Hold on. Sorry, this computer that had the Slack chat just died. I'm going to try to plug it in. So people are asking an interesting question in the chat, which is like, well, can I just check if things are within a certain range from the bubble? Well, how do you know if things are within a certain range of the bubble? Oh, just check all the bubbles to see which ones are within that range. Well, you're checking all the bubbles. So there's a way of being able to kind of register bubbles in different areas of the screen and then reducing the number of checks you need to do based on where they're pre-registered, so to speak. Sorry, I'm kind of opening this computer back up. Oh, the battery died on this computer. Wow. Oh, let bubble. Oh, did I not do let? Oh, this is supposed to have let in it. I'm so sad. This should really have let. I just kind of like forgot to put that in there. Should really declare it. Oh yeah, shoot. All right. I don't know. Just see if this can like magically get spliced back into the middle of the video somewhere, or just right before the end. I doubt it. This computer is totally crashed. Can't get the Slack. It's completely frozen. Sorry, everybody. Just give me a second here. Sorry, everybody. I'm just kind of trying to get this other computer back up and running. Yeah. Today's JavaScript's 22nd birthday. I did not know that. Okay, hold on. I'm just looking through this. Okay, so how am I going to fix this? How am I going to fix this? Okay, so one option is, maybe I could do the thing that I've always wanted to do. Hold on a sec, everybody. Just give me a second here. This is ridiculous. Poor Mathieu. This is going to be so entertaining. Let's just temporarily turn off that. Okay. Wait, a better idea. This is a terrible idea. A little behind the scenes moment here. The problem is I can't get the let. We'll see. We'll see. Let me just try this. This is probably not going to work. But you guys will be entertained nonetheless. Oh, hello. You're wondering why that video just stopped and I appeared again. It's because I did forget something important and I'm going to add it into the code. But when I use this new loop with for b of bubbles, I really forgot to declare b using let. Otherwise, it kind of like JavaScript just. Let me try this again. Try to get this explanation. Oh. Sorry. I had to stop that video. I made kind of a mistake that's sort of important. When I used the new loop where I said let b of bubbles, I forgot to declare, for. Sorry, everyone. I just have to pause this video for a second and come in to correct a kind of mistake that's here. When I use this new loop, for b of bubbles, I forgot to declare b and say for let b of bubbles. That would really be much better. And hold on. Settings. Wait, hold on. Settings. No. Here we go. Filters. Okay, hold on. Okay. What am I talking about? Right there. It should say for let. And then now I'm going to go back to here and. But it's not actually in the original video. I will add it to the code when I upload it, just so you know. Okay, bye. Enjoy watching the rest of the video. Okay, so that's one possible way to correct it. One possible way. Record scratch, yes. I don't have a record scratch sound. Somebody sent me a breaking news sound effect, but it was kind of like generic. What I want is like, coding trade, breaking news right now, something like that. Anyway, I really need someone to just like become the sound person for this. I need more music, I need better sound effects. It's all awful, but okay, hold on. Let me come back here. And I'm gonna give Mathieu a second option to correct. How do I turn this back on? There we go. Second option. There's a weird jump cut in this video because I just coded this, but I forgot something important. Wait, hold on. I'm going to, because this overlapping stuff is actually not in that part of the video. So what I'm going to do is, there's a weird jump cut in this video because I just coded this new loop and I forgot something important, which I really should use let to declare the variable that's going to stand in for all the elements of the array. So that's a correction there. It'll be in the code when I upload it, but as you go back into the video, you won't see it there. Okay, that's another correction option. And then, I can't think of, and then let me put it in. And the other option will be just at the very end. I'm still here, the video hasn't finished yet because all the while I did make kind of an important mistake, which is that in this loop here, even which is other is a variable that's standing in for every element of the array. That variable really needs to be declared using let so that it is local to the for loop. Otherwise, I could run into problems, okay? So now I am actually at the end of this video, unless I come up with another correction, and I'll see you in a future one. Ah, I'm forgetting the outer loop. Wait, don't go. I'm forgetting this also needs it here. Oh, the whole time I should have been doing this with the outer loop. Nah, what a terrible fail. I finally saw that. Another correction option is CGI. Oh my God, I can't go back and redo all those corrections. I'll just do one for the end. That's probably what we're going to end up. Another day I'll use my crazy record scratch. I stop and re-enter the video. But let me just do one at the end. Okay, this video is not over because I have noticed a pretty fundamental mistake here, where in both of these loops, right, for b of bubbles, where b is a variable that stands in for every bubble in the array, just like if I'm going to say for let I equal 0, I is less than bubbles.length. If I'm doing a loop like this, I really need to declare that variable b. Otherwise, it could be, mistakes, bad things could happen. So I should have let b here, and then of course I'm doing this again here. I should say let other of bubbles there. So hopefully you didn't spend too much time screaming at your viewing device while you're watching the video, and there it is at the end here. Okay, thanks very much. All right. All right. So, I'm doing a bad job of saving these as separate versions. Ugh. Well, let me try something. I'm going to do copy, paste. And don't everybody start telling me that I should be using Git and GitHub. I'm not going to commit all my changes like in a live tutorial setting. I use those tools for myself. But what I'm going to do right now is I'm going to undo this all the way back to what it was at the end of the first video. Whoa, maybe it doesn't go back that far. Oh, yeah, it does. Yeah. Look at this. It's like everything I just did in reverse. OK. So I think this is it now. Whoops. What happened to my browser? Bubble 1 is not defined. Oh, a couple more changes, but I will just, oh, shoot. So this is now the end of the first video. Okay, and now what I'm going to do, whoops. Now what I'm going to do, I just need to save this code so when I get uploaded later. Desktop 07 on this. It's very low. I'm going to do come on, copy this thing. Copy. And this will be 7.7. Come on. 7.7. And then I'm going to go grab this code and put it in sketch.js for 7.7. So now I should have 7.6 is this example, and 7.7, oops. That's not where I wanted to leave it. I should fix that now. What do I want? I want like 50 of these, 10, 50, or maybe 20 of these. There we go. Okay, so that's where I'm going to leave it. Okay, so those things are done. Now, guess what, everybody? Happy times are ahead. Okay, I'm looking at the chat. Oh, let me do that video right now. Where's that going to go? So this is going to get inserted in, oh, the numbering is going to have to change. Is that bad? If I'm going to actually do a video where I explain that other loop, that would have to go. That would have to go. This would have to go. What is an array? Arrays and loops, arrays of objects. I guess I could put it here. Oh boy, that would renumber. I mean, is it a big deal to renumber all these things? I could also make it like 7.3b. 7.3b. What happens in this video? Yeah, let's look at the code for that one. 7.3 arrays of objects. Right. This would make sense for me to just do that right here. I probably shouldn't have done it in that other. Okay, let's call this 7.3b. What is this called, by the way? Ah, come back, computer. Like in Java, when this new kind of loop came out in Java, it was called the enhanced for loop. So let me see if I could find it. JavaScript of loop. For of. Okay. So it's called the for of loop. For variable of iterable. Okay. Yeah, we're going to do this as like 7.3.1 or 7.b or whatever. This is going to be one of my record short videos. I could just see the money falling from the sky when I make lots of 1-minute videos that everybody watches. No, it's really not going to happen. It's a nice idea, though. Okay. I could also do it before I even get to the objects, but let's do it there. Okay. Woo, it is me coming from the phone. Let me go back. 7.3. Oh, hold on. It drives me crazy. Let me get rid of the sound library. I'm here to tell you about something that's kind of exciting that I really should have known about when I made this video, but it's new to me, and it's now going to be new to you, or maybe you know about it already. But I'm going to show you this new loop in JavaScript called for of. I think that's what I'm going to call it, for of. So very, very often, the previous example that I just made, right, this happens all the time in programming. Hey, I've got an array of things. Let me count through the whole array to act on everything in the array. And this can happen with arrays of objects, like I want to move and show all these objects. It could happen with arrays of numbers, like, let me double all the numbers in this array, or let me add up all the numbers in this array. And there's actually other ways of doing that too that I'm going to get to in other videos. But what I want to show you here is the for of loop. So really what this is saying here is for every bubble in the bubbles array. The problem is, I think in already meant something else in JavaScript, or each always means some, there is a for each thing. So I'm speculating here, but I imagine when this feature came into JavaScript, the developers needed a word to pick, and that word is of. So what I'm actually going to say is like, this bubbles index I stands in for every element of the array bubbles. So I can actually do the exact same loop by saying for let every bubble of bubbles, and then bubble.move, whoops, not bubbles, and bubble.show. Now, one thing, so this is what I want to emphasize here. These are exactly, and I'm going to step to the side here, these are exactly the same. Let me move my mouse out of the way. No, it must look perfect on the screen here, right? This is me counting with an index to address every element in the array and moving and showing them. This is me just saying, hey, JavaScript, I don't feel like counting today. Could you take care of this for me? Just give me every single bubble in order in the array bubbles and move and show them. Now, I'm going to do things in later videos where I start deleting things out of the array, or maybe I only want to use half the array. Then those are cases where I really need the counter. There are often cases where the counter plays a role, but if the counter doesn't play a role and I just want to do something to every element, this is what I could do. Now, what I don't love about this, and this is, I do this all the time and lots of programmers do this, is I have a class called bubble. That's capital B down here. I have an array called bubbles, lowercase b, with an S on the end, plural, because it's many. And then I have bubble, which is like an individual bubble in the, that's every bubble of the array. So I just want to emphasize that this could just be called, if the bubbles names were unicorn, this is just a made up variable name. It is the word that stands in for every element of the array. And so like I could say let element of bubbles, for example, but this is kind of a convention that I could adopt. The class, the type of thing is capital B bubble. When I have an array of them, I'm going to call it bubbles with an S. When I have an individual one, I'm going to call it bubble. But there's no reason why you have to call things that way. I could call this bubble class, single bubble, bubble array, that kind of thing. So that's really it. I'm going to use this. I'm going to use this kind of loop in other videos, and then I guess I can reference back to this one when I do. Hopefully this made sense. I'm looking around to see if anybody has any questions. But you are in the future. I don't even know who you are watching this video, but you are there someday watching this video. I'm probably not standing here anymore. I'm somewhere else. This video has ended. For each. Yeah, I don't like the for each. I don't know why I don't like the for each. I have a problem with for each. Everybody knows about my fear of for each. Okay. I don't think, to be honest, I don't think this video needs a code example. Please stop using semicolons. No, I will never stop using semicolons. Oh, I'm even going to add arbitrary extra semicolons for no reason. Okay. So let's get out of here. And I've got one more of these objects videos to do. Wow, everybody is using this, thank you, Nolan, using the, what's the YouTube thing that it has that's like the chat room tip jar? It's very kind of you all, thank you. I know you wanted to see the boys, surprise. It's kind of working on me, but all right. For each isn't so bad with arrow functions. Oh, you're so true. Super chat, thank you. So my I don't know, I don't have a preferred way. I guess I'm going to leave the super chat thing enabled. It is a way that people can make a one-time donation if they're feeling so inclined. I also do have a Patreon. I have been considering looking at some other platforms actually, but I don't want to get into that right now. Okay, so here we go. Now what I need is a small collection of public domain or Creative Commons licensed images, ideally with transparent backgrounds, like a bunch of flowers, a bunch of kitty cats. Where can I find that? Where can I find that? How many people are watching, by the way? I haven't checked that in a while these days. Oh, I can't see. It doesn't show me on this page. Why am I not signed in here? Okay, thank you. Sorry, I didn't have my YouTube dashboard page up where it tells me how many people are watching and that sort of thing. Ah, the meth, you got the method channel. Those are great videos, yes. Yeah. Okay, sorry. I lost my train of thought. All right. I think the for each loop is perhaps a bit more powerful in that you actually have essentially a callback function for every element, whereas the for of is just a way of addressing each element. So, I think for what I'm doing here, this is much more readable than for each, but maybe I'm also just not. So I guess the for each way would be for each. No. Bubbles for each. And then I could say be something like, something like that would be for each, but I'm just kind of more of a fan of this. Okay. I'm not ready to get into that yet. All right. Let me see. Oh, those bubbles. All right. Okay, so I need some images. Anybody got images for me? All right. Images. Let's see. What did I use in olden times? I deleted those. So what did I use back in the previous tutorials? P5JS. If I go to 7, I did the objects and images. Oh, I just used these flowers. So where did I get them from? I could just use these again. So people are asking about, so you can actually contribute subtitles via YouTube if you want, and I'm very grateful that people sometimes take the time to do that. It's my goal to have all the videos captioned to make them more accessible, not to mention translated into other languages if that's possible. All right, what about your kittens from the browser extension video? Thank you, good idea. So let me go to Chrome extensions, kittens, all right. We're going to get some kittens here. Everybody bear with me for a second. So now I need to go back to 07 and make kittens, and let's get the essence of these kittens boiled down. Adjust size. I would have liked to have some transparent. Let's just do it like 100. There's a kitten. There's a kitten. Another one. And oops. Here's another one. And oh, they're not going to be circles anymore. That's fine. Whoops. Here's another kitten. Whoops. I think I've got some extra unused, unnecessary pixels there. Adjust size. Whoops. Whoa, did I just make that 100 inches or something? Yeah, whoops. Sorry, I know the camera just went off. Okay. Now, kitten 1, whoops. Kitten 0. Kitten 1. Kitten 2. Kitten 3. Kitten 4. Okay, so now I have a bunch of kittens. Maybe I'll just start from, trying to think here. What makes the most sense? Maybe I will go back to mouse interaction with objects, arrays of objects. What's going to be the best one to turn into? Oh yeah, let's do this one. Okay, so let's do mouse interaction with objects. And this one's going to be us. This one's going to be 7.8. Images. Okay. Let me just look briefly. What did I do in the previous tutorial video that was there? Hi, so I've got one last video here in this one is you make your own flowers, make better flowers than me. But you can see this is kind of important to think about as you construct. This is really I run. So, but so the plus with text with characters between quotes means concatenation or join. Oh, because I loaded them. All right. Did I use preload here? Ah, okay. All right. I got it, everybody. Don't worry, everybody. Everything's going to be just fine. Images and images. Let's get rid of the sound library. Kittens. And now I need to put in the kittens folder inside here. Okay. All right. So one thing I want to do is trying to decide. Whoa. Pete in the Slack group just gave me a great category, flowers with transparent background. Flowers with transparent background. Do I dare move away from the kittens? Oh, these are such nice flowers with transparent background. What about kittens with transparent background? Kittens with transparent background? I don't know. Do I need to straw poll the kittens versus the flowers? This is definitely a really important, good use of our time, don't you think? I'm going to stick with the kittens because I have them already. And I will mention, I will grab, kittens and flowers. Ooh, I just got a little dizzy there. Let's grab one of these. I like this cactus flower image. And flower.png. No. Not the web page, silly goose. Save image. Flower.png. And I'm going to start them all as flowers. And when you click on them, they turn into kittens. Ooh, ow. How did it get to be 4:15 already? I just spent like a half an hour organizing directories of images of kittens and flowers. I'm very sorry. It's time, I think, to take a sponsor break. As you know, Coding Train is sponsored by water. If you don't drink it, you might die. Something like that. Okay. Okay, here we go. Don't change this. Okay. I can do it. I can write this code in a way that will make sense to people and be useful to somebody someday in this world. Hello, I think at this point, until I make some more, this is the last video in this section about arrays of objects. And one of the things that comes up a lot, especially when you're first learning to code, is with P5 and doing graphics and animations, everything I've been doing pretty much in all of these videos has just been with shapes. And so as you can see here, here is one of the examples, arrays of objects, where when I click on them, they change color. This was one of my previous videos. What I want to look at is what would it take to have each one of these circles, each one of these objects display, instead of a shape, an image, a JPEG or a PNG that I load, a file that I load, and how could I have the same object? So how could I make a bubble class where each bubble displays an image, but each bubble displays a different image? So the first thing I'm going to do is just change all of these into flowers. Okay, so I have a directory. I have a directory of images associated with this project. Let me go over to my code, and it looks like this. It has a bunch. It has one image in it called flower.png, and has a bunch of other images called kitten.jpg. The reason why I'm making this distinction is PNG is a format for images that allows for transparent pixels, and that's something that you're probably going to find very useful when designing and using images in your code. That you can have an image not just be that sort of like rectangular thing, but rather have part of the image be transparent. So, okay, so let's first, I'm going to, one of the things, if I want to load an image into P5, there are a variety of ways to do it, and I'm sure I have other videos in the future, even though I'm in the future, but I made in the past, but they're further ahead in this playlist, where I look at this more specifically. But a quick way to load media, it seems a little bit silly, like, oh, there's a preload function? Setup is the function where all the code at the beginning runs. Well, I want to load images at the beginning to use. I should use those in setup. But there's a funny way about JavaScript, the way that it loads media files and large data files, is that it can sometimes take a while for those things to load. So the preload function is a way of saying, I'm going to have a variable. I'm going to call it flower. And in preload, I'm going to say flower equals load image flower.png. And this could be double quotes or single quotes. They mean the same thing. I like single quotes these days. So this right here is saying, hey, I know you're about to set up the P5 sketch. Before you do that, I want to have a pre-setup to the setup where I want to load this image. So this will guarantee that the flower image is ready to be used by the time you get to setup. Now, the rest of our work is really as simple as if I have this image, that data from that PNG file stored in this variable flower, I can just go all the way down to my bubble object and look here. This is where I draw the bubble as a circle. So I can just get rid of all of this code, and I can just change and use this function called image. So there's a function in P5 called image which says, hey, I want to draw an image to the screen. Just like I want to draw an ellipse at this.x, this.y, now I want to draw an image at this.x, this.y. So now all I've done is load that image in preload in a global variable and then draw that image here in the show function. So let's refresh and okay, so what is this error? File not found. I forgot that I put the images in this directory called kittens. So I need to make sure I reference that directory. Now note, I also need this directory to be part of the same directory where my index.html and sketch.js stuff is. So there can be some nuance here into where you store your image files. But in this case, I just need to make sure I include the folder name kittens/ flower.png. And now if I do this, we can see, look, there, my bubbles are flowers. Yay! Now, they are different sizes. And so if I wanted to, I could kind of go a little farther with this, and I could use this variable r, and I could make that the width and height of the image. So one thing to realize here, I'm looking over there to see if I can use my whiteboard, which I'm about to, but I have to go erase it first. Hello. Talk amongst yourselves. Oh, I'm so happy to be done with this. The problem with this is the next time I'm going to use this for my courses, although, it's like next year, I'm sure I'll have to redo them all again next year also. It's okay. It's okay. Such is the Sisyphean task of teaching JavaScript. Where's the marker? Where's the one good marker? Maybe this is it? So when I drew a circle, when I used the ellipse function, and I have this variable called this.r, I actually assign that, it's poorly named because it's assigned to the diameter of the circle. A rectangle or a square, which is a rectangle with equal sides, if I have the x, y here, this is its width and this is its height. The reason why I'm bringing this up is because the image function, I switched from ellipse to image, but it would be almost a better example if I were switching from rectangle, which requires an x, a y, a width, and a height, if I were switching from rectangle to image, which also requires an x, a y, a width, and a height. The only difference is fill that rectangle with the pixels from some actual image, like flower. So this is really what's going on. So I can manipulate the size and that sort of thing. I'm not going to worry about that too much. And I'm just going to leave it. I'm going to just simplify this example. But let's just show it to you with r in there. You can see now they're all different sizes. I'll leave that in there. Why not? OK. All right. So now, what if what I want to do is click on these and have them change, transform from a beautiful flower to a butterfly? Because we all know butterflies transform. OK. I have kittens, to a kitten. Oh, I have kittens. So I do have this clicked function, changes the brightness. Let's just first make this work. I'm not making this extra complicated. Time out. Let's put some kittens. OK, I got to keep going. This is fine. Let's back up a second. And what I want to do now is I want to, instead of having each bubble object be the same image, I want to pick an image of a kitten. So I'm now going to add an array called kittens. And what I'm going to do is in preload, I'm going to say kittens index 0 equals load image kittens kitten0.jpg. So you can see here, right, I could do this, right? And I had 5 of them. So here's the thing. This is pretty horrible. What I want to be able to do is if I have a whole bunch of images and they're named in some consistent way, what I actually want to do is could I write a loop to load all of these? So instead of having 3 images loaded into an array, 0, 1, and 2, could I write a loop? And one thing that's interesting is I can do this very easily with something called string concatenation. Nice excuse to bring that up in here. So as you might know, 2 plus 2 equals 4. However, A plus B equals the string AB, or cow plus bell equals cowbell. So when you use the plus operator with text, it joins the text rather than the plus operator with numbers adding the numbers. And the reason why this is so useful is what I can do here is I can write a loop for let I equal 0. I is less than, how many kitten images do I have? I think I had 5. I can see them here. 0, 1, 2, 3, 4, I had 5. 5, I plus plus. Then I can just take this line of code, put it here, and I can say kittens index I equals load image kitten. Now, I don't want to load the 0 kitten into each one, although I could do that now for just testing, but I'm going to keep moving on. I want to load this plus, oh, and there's a new way to do this. There's a new way to do this in ES6. I'll come back to that at the end of this video if you're interested. Because this is the old way that I can add the I in between. I can say, take this string, kitten slash kitten, join it with the value of I, which is 0, 1, 2, 3, 4, and then add .jpeg to the end. And that will load all of those image files into kittens. Now, let's just make sure this works by going down here and saying something like kittens index 0. That's kitten 0. Let's take a look at kittens index 3. That's kittens index 3. Look at that little kitten. Little kitten. OK, so now, how do I have each object have a reference to a different kitten? Very important. So one thing that I think that I want to have, I'm going to get rid of this brightness thing. This brightness was from a previous example. What I want to do is have an image associated with each bubble object. So why not say this.image equals, or this.kitten equals what? Image. So when I make a bubble, I want to say, I want a bubble to be at this X location and this Y location with this size, and I want it to use this particular image. So what that means is I need to now up here, I need to pick one of these images. Now, let's say I want to pick a random one. The nice thing is, if you have an array in P5, I can just say kitten equals random kittens. This random function, if I give the random function an array, it will pull out a random element from that array, which is one of those random kitten images, and put it in this variable. And then I can pass that in. So this is me picking a random image, then passing it into the object, and then the object receiving it and putting it in as a property. And then what's the last step? I need to make sure I draw that particular kitten image. All right, let's see what we got here. Yay, look, lots of random kittens. Now, it's hard to see them because they're so small. So let's make these kittens bigger. There we go. So you can see, yeah, I have a bunch of kitten objects. And I do the thing where I click and I add new ones or I delete them. But let's have all of these kittens, every time I click, change to a new kitten. So we already had this whole clicked function. And I'm saying if D is less than this.r, why not just say this.image, this.kitten is a new random kitten. So we can see I could always at any moment pick a new image to store into that bubble object's image variable. And so now, oh, and this is bad though. This is for checking that function, this math that I had left over from before is checking to see if the mouse clicks inside of a circle. And since the image is actually a rectangle, why don't we make those back to flowers? Because the nice thing about the flower is it was kind of like a circular thing inside. Whatever. But I could change this code. I could change this code to say if px is greater than this.x and px is less than this.x plus this.r, and py is greater than this.y, and py is less than this.y plus this.r, right? What is all this crazy mumbo jumbo that I just put in there? What I'm trying to do is I'm trying to say, hey, there's a point. It's clicked. Is it in between this x? Oh, you can't see that. This x. And this location is x plus r, and the y is between this y, and this location is y plus r. So I'm checking to see if the x and y of the mouse is within those boundaries. And once I've done that, we should. Yay, look. I could just keep making different kittens. Yay. It's not a square. It is a square. It is a square. It's not a square. I don't know. So I've done something goofy here where I'm just, you could clean this up and try it different ways. And what if I make it a flower and is a circle better to check? Maybe I could just change it when I click to flower. So these kittens are changing into flowers when I click on them. And then if I click on them again, oh, they still are a flower. So you can see the range of possibilities. You can also make the argument here that maybe this whole picking the random kitten here and passing it in was kind of unnecessary, because what I could have just done is right down in here, I could have just picked the random thing in the constructor, and that's also the same thing. So there's lots of different ways of organizing the code depending on what you're trying to do. Generally speaking, I don't love the fact that I'm using flower here or kittens here, because these are variables that exist outside the scope of the class. And the class, if it's going to know about things outside of its scope, should probably receive them as parameters to a function. But that's neither here nor there. It's worked. Oh, is everybody asleep now? Thanks for watching this video, and that's it. Now you can make all of your objects and all of your things that you're doing images. Okay, everybody. I think I've done it. I have suffered through, you have suffered through me finishing these intro to object-oriented programming with classes in P5, and those videos will hopefully help people in the future as they go through the playlist and get more used to stuff. Okay. So I want to make sure I do a coding challenge. I think what we'll do, I still have a little bit of a cold left over. Hopefully that didn't blow out your ears. Oh, the other, shoot, I forgot about that. Okay, hold on. There's going to be an addendum. Does anybody tell me what that's called? It's like the way that you, in ES6, you use the backtick to concatenate a string. I forget what it's called. Backtick JavaScript string. Does that have a name? Template literals. Why is it called that? Embedded expressions. Yeah. Okay. Okay. Wait, there's a bonus here at the end of this video. I don't know why I'm looking around as if someone's going to catch me. I forgot. I should probably make a video just about this, but while we're here, there's also a new way. Look at this. And I was told, by the way, I was just given some nice advice about, I shouldn't really be using the word join because that's kind of used in other, but this is string concatenation. Kitten/kitten plus concatenate with the value of I plus concatenate with .jpeg. But there's a new way to create strings from actual characters and variables in JavaScript. And it's something called template literals. And this is in lots of other languages, but this is a new way to do it in JavaScript. And it involves the use of the backtick. So if I put backtick here and backtick here, get rid of this, get rid of this. Now I don't want the pluses anymore. So this is just like a string. It's a literal string. Literal. This is a literal string. Kitten/kitten.jpg. But if I want to use a variable in there, while we're calling this a template literal, I can put a variable in there with curly brackets and $, and then the name of that variable. Hopefully I'm getting this right. So this is a way of saying, hey, I want to have this string, instead of having to use plus for drawing. And the nice thing about this, I'm pretty sure it lets you do this over multiple lines too, which is really, really nice, because with regular quotes, you can't have multiple line breaks. So this should work exactly the same way. Template literal. So close. What did I get wrong? Oh, right. Thank you. I made a mistake. Because, by the way, I don't actually know what I'm doing at all. It looks like this. The dollar sign, I knew it should have syntax highlighted that in some way. The dollar sign is an indication like, hold on a second, I'm going to use a template literal. And so now it's saying what's inside of here is the variable name. And we can see the syntax highlighting fixed, which is good. There we go. Now this is working, and it's the same exact program. I should mention, well, what if I really wanted to have, so one thing, if I just had like dollar sign in the string, it's not going to think it's part of this unless the curly brackets are there. And so if I really wanted it to be this, I could probably like use an escape sequence or something, but it's pretty rare that you're actually going to want to have this sequence of characters in your string. Okay, so that's a little extra bonus piece at the end of this video. Maybe I'll make a special video just all about the wonder of template literals, because that's what I'm sure everybody on the internet wants to watch, and I'll see you in the future. Okay, all right, I'm finally finished. Woo! That's the sound effect I like better than the sad trombone. Okay, I'm gonna leave that like this. All right. What is the tag? Oh, you can do like an expression. So you can actually evaluate code probably in there as well. Tag, template literal, all right. Multi-line strings. And you can use expressions. Yeah, look at that. Fascinating. Nesting templates. Okay, this is too much for me. Okay, am I really going to do the game of life right now? Is that a good idea? Is that what's happening today? Let's look at my, I definitely don't feel like doing the advanced array functions because I want to do something a little bit more creative and interesting. This, by the way, this is what I got through so far. really getting through this list. People want to vote. That's interesting. Multi-line strings, yes. All right. Okay, I'm going to do a straw poll because why not? Well, that was a good Mappa Game of Life Boyds. Let's try the straw poll. Well, let's just do Game of Life versus Boyd. Yeah, why not? I don't think I should do the Mappa right now. I'll do that later. Challenge. The reason why I like doing the Game of Life is because I could turn that into 3D. Automata. Do I say automata? Is that how you spell? That's not how you spell cellular. Boyd, I'm really gonna like program the whole Boyd simulation thing from scratch. All right, let's give this a try. I feel like if I put Mappa in there, it's not gonna get the votes, and it's gonna. So here. I may or may not choose to listen to you. But it's useful information. Big screens, yes. No, I'm okay. I got to get over there, but it's 4:40. I'm okay still. Thank you, Dolly, for reminding me. Boyd's can be 3D too. That's a good point. It opens up a big can of worms, though, in terms of like how to draw them. Whereas Game of Life in 3D, it's kind of easier to just go from like a square to a cube. Did somebody post this in the chat? Oh, wrong camera. Sorry, the mouse is covering. So while you guys are voting, I'm gonna erase this. Then I'm gonna go onto Amazon.com and order myself a big box of whiteboard markers. What would you guys think about, I've been looking at these glass systems where I could hang a big piece of glass right here and draw on it like this, and then I would just like flip the video, so I'd be drawing and looking at you and standing behind the drawing. I don't know, I'm kind of used to the whiteboard thing though. All right, let's see where this is going here. No, interesting. All right, this is pretty clear to me. So I have to remember the game of life. So let me, oops, you guys didn't see. This looks pretty good. Let me look for a couple things. John Conway, Game of Life, Scientific American. Right, so there's this. And then Game of Life, probably Wikipedia. Be a good place to have the rules right here. Oh, I remember why I was going to do those advanced array functions. Is because I was going to use them in this. It's not really that much that I need really map or reduce. I could use fill probably nicely, or just like set them randomly. I'll skip that. I'll come back to that. Okay. Okay. Yeah, and it's funny. This is so funny to me that so many people are posting in the chat. Dagara LP just wrote, "Didn't you already do Game of Life some time ago?" Well, the thing is, I did not already do Game of Life some time ago. As a coding challenge. I do have it as part of my tutorial series, and mostly I get people asking me to do it, so I thought maybe I would just do it as a coding challenge. You know. All right. The volume is low? Oh, I could definitely raise that. Did that just happen just now, or has it been all the way? Patron group in the Slack, could you confirm to me that I should raise the volume? The other thing I like about the Game of Life is it's ripe for user contributions. Volume is fine, okay. A refactor video. Okay. That's fine. Okay, great, thank you. Thank you, okay, I've got the message, all right. Okay. So, okay, so this I'm also going to refer to. I wonder when I recorded this video, a long time ago. All right. Let's see. Let me open up processing. Oh, if I want to update the code to use the new array functions later. Okay. Sorry, I'm just... CA, sorry. I just thought wraparound, simple. This is very silly what I did in this example. Yeah, okay. Ah! This is probably going to be bad for YouTube compression. Okay. That's better, maybe. Should I slow the frame rate down? Yeah, I'm going to do this in JavaScript. I just was opening the processing example so I can make something nice and full screen. Maybe I can just slow it down by not doing P2D. Yeah, this is probably pretty good. All right. All right. Oh, wait. I should probably get the code stuff ready. Let me do this. The thing that I don't love about doing this in JavaScript is the whole 2D array thing is so awkward. Could just make it a 1D array and have a function always return the value with a given column and row. I don't know. Is a good question. Okay. I'm going to slow this down. Let's make this 24. That's pretty good. Yeah, okay. Yeah. Oh, 3D arrays. I'm going to make a 2D version in 3D where you just look at it from above. Sorry, everybody, I have to go to big screens now. Oh, boy. All right. So here we are. Wait. Sorry, I'm still not ready here. Okay. All right. It's time for a new coding challenge. And today's coding challenge will be to make the game of life. This is an example of the game of life that I made many years ago in the program environment processing. It's going to run for a while. I can click and kind of start over with a new random set of tiles. Now, you might be asking yourself the question, what is the game of life? I'm not going to spend too much time on that in this particular video, though I encourage you to look at some links in the description to find out some historical background, what's possible, all the kinds of variations and things you can do with it. But it is an example of a cellular automata. I hate that word. Wait. Automata. I meant to like sort this out for myself so I wouldn't have this problem. Pronunciation. Oh. Why won't it tell me?
Automata.
Automata. Okay, automata. Let me just start over. And drink some water. Automaton. I can't even remember now. Hello, welcome to today's coding challenge. In today's coding challenge, I'm going to attempt to program this, which is the Game of Life simulation. I'm going to do it in JavaScript in the browser. This is an example that I made several years ago running in the processing programming environment. I will also link to the code for this version. So you might be asking, what is the Game of Life? Well, great question. I encourage you to check and read some of the historical background. This is an article from Scientific American in October of 1970 by Martin Gardner about the mathematician John Conway, who proposed this cellular automaton, the Game of Life. It's an example of that. Wait, no. Every time I say that word, I freak out. Like I sound stupid or I'm saying the wrong thing because I cannot pronounce it. Was interested in a problem presented by blah, 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 blah. I mean, his first public appearance, was it called a cellular automata then, or is that more like Wolfram coined that term? All right, hold on, everybody. Give me one more chance. I know what's missing. Hey, hello, welcome to today's coding challenge. Today's coding challenge, I'm going to attempt to create this, the Game of Life cellular automata simulation. Automaton? Automaton. Please don't make me say that word ever again. You can't pronounce it right, someone is always going to complain. I'm going to just get it wrong. Example of a, if it's an example of a flower, you wouldn't say example of a flowers. So it's an example of a cellular automaton, which, automaton, that I can say. This is the last time, I can't start over again. Hello, welcome to today's coding challenge. In today's coding challenge, I am going to attempt to program this, the Game of Life cellular automaton in JavaScript. I'm going to use the P5.js framework. What's running right here, right now, is a processing example using the Java programming language that I made several years ago as part of the Nature of Code book. Now, if you're interested in that, you can also look at my whole playlist about this thing that I can't pronounce called cellular automata, the plural of automaton. And I do have some videos that give you some historical background and looking at different Wolfram's elementary CA and some exercises and things. But I'm really just showing examples and talking about the systems in those videos. And in this video, I'm going to try to just start from no code and finish with the simulation. Hopefully it's going to work. It generally doesn't, so don't get your hopes up. But I do want to say that I would encourage you to do some background reading. This is the first sort of public appearance of the Game of Life as created by John Conway, a mathematician, from an article in Scientific American in 1970 by Martin Gardner. Of course, you can always refer to the Wikipedia page. I'm going to need this, which is going to where it outlines the rules for how the system behaves. And you can also see that there's a lot of possible stuff. There's all these kinds of interesting repeating patterns and different types of things that you can create and do with the Game of Life simulation. But I'm going to program a simple version of it. Hopefully that will happen. Then at the end, I'll talk about some variations that you might think about, and maybe someday I'll even try to make one in 3D or something like that. Okay, so let's get started. Here's what we need. A cellular automaton is a system of cells that exist in a grid. It could be in 1 dimension, 2 dimensions, 3 dimensions. The Game of Life system is one that exists in 2 dimensions. And the idea is that you have generations. Let me pause for a second while I just try a different pen here. Not this one. Yikes. I put them next to each other. That was a terrible idea. So if this is generation 0, I'm going to run some computation on this system of cells on a grid, and then I'm going to have a new set of cells on that grid, and that's going to be generation 1. So the cells that exist on that grid all have a state. That's part of a CA system. So that state could be a floating point number, it could be a kind of animal. You could really imagine it in a lot of different ways. I'm going to do something very simple with the game of life is a simple system of discrete states, 2 states, 0 or 1, on or off, alive or dead. So you could imagine a configuration of this being something like this. And for each time, each tick, each generation, each frame of animation, I evaluate each cell one by one and get a new state based on the previous state. So let's say I'm trying to do this cell. I need this cell's new state. I'm going to get a new state based on this state and its neighbors. So what are its neighbors? That's up to us to define. It could be its left neighbor, its right neighbor, it's only its neighbors to its left. But in the game of life system, its neighborhood are the 8 cells surrounding it. So it's this 3 by 3 area. 1, 2, 3, 4, 5, 6, 7, 8. So I need to evaluate all of those cells and decide whether it should stay as a 0 or turn into a 1. And the reason why it's called the game of life is the rules for how we move from one generation to another resembles some type of like biological process that you might think about population or bacterial growth. And the idea is that a cell that is surrounded by neighbors that aren't alive cannot stay alive. A cell surrounded by neighbors that are alive can come to life or stay alive, and a cell that's surrounded by too many neighbors cannot stay alive due to overpopulation. And we can go back to the Wikipedia page and read those rules precisely right here. So any live cell with fewer than 2 neighbors dies as if caused by underpopulation. Any live cell with 2 or 3 neighbors lives onto the next generation. Any cell with more than 3 neighbors dies by overpopulation. And any dead cell with exactly 3 live neighbors becomes a live cell. So this is written as if by reproduction. So this is written in a somewhat of a confusing way. I think I could simplify this, I think. We could say, like, let's say the cell is dead. It's a 0. It's only going to change to a 1 if it has 3 live neighbors. Then it changes to a 1. Otherwise, it stays a 0. A 1 is going to stay a 1 unless it has less than 2 live, and greater than 3 live. Then it dies. So reproduction happens with exactly 3 neighbors. Death happens with fewer than 2 or greater than 3. Now, I don't know if I got those numbers right. Let's go check the Wikipedia page again. Ah! Thank you. This video, I hit the sound effect by accident. Apologies for that. Live cell with fewer than 2 live neighbors dies. Yes, less than 2 dies. Live cell with 2 or 3 neighbors lives. I don't care about that. I'm not going to kind of not care about change. Then it stays the same. I can kind of ignore that. Live cell with more than 3 neighbors dies. Yep, that's what I've got over there. And then any dead cell with exactly 3 live neighbors becomes alive. Okay, so I've got those rules correct. So now, what do I need? Hello, you're over there. I'm going to go back over here. I need something. I need a data. All I need to make this program work is a data structure to store this grid. And this is where I'm kind of having like a bit of a headache and I'm really not sure what to do. The way that I've always done this in previous examples is by using something called a 2-dimensional array. And I think I have a video tutorial about that somewhere, which I will link to in this video's description. But 2-dimensional arrays are kind of not so much fun in JavaScript. They can become a little bit weird. And there really is no such thing as a 2-dimensional array. A 2-dimensional array is a construct of our own human mind, saying like it's really just an array of arrays, which makes sense. This is an array. Each row is an array, and then the grid is an array of rows. Or each column is an array, and the grid is an array of columns. So I think I'm going to do it that way with a 2-dimensional array. I just should say that it's a little bit awkward, 2-dimensional arrays in JavaScript, but I'm going to go ahead anyway. So the first thing that I want to do in this program is just make a 2-dimensional array that stores a random collection of 0s and 1s. So let's go do that. I'm going to go to the code, and you know what I'm going to do? I'm going to actually just write a function. I'm having like weird deja vu. I probably did this in another video somewhere. I'm going to just write a function called make 2D array, and I want a certain number of columns and rows. Okay, because that way I can just say, I can have a global variable called the grid. I'll call it grid. And I could just say grid equals make 2D array. And I could say I want a 10 by 10 grid. So this is kind of what I want to do. I'm going to just farm out the making of the array to another function. And now I do remember doing this. Because I'm going to write this in a kind of, there's a whole like coding challenge or video. I'm going to do this in a kind of horrific way. And then everyone's going to like give me all these like amazing ES6 JavaScript fancy ways of doing this whole function in like one line of code. Someday I'll come back and do that. Okay, so now let me see here. So what I need to do is first is I need to have some sort of array. And it's going to be, this is always where I get confused too. Do I want the columns? The point of using a 2D array is that eventually at some point I'm going to be able to say something like grid, index 2, index 3. And I guess I usually think of this as x and y, and x being the columns. So I want the outer array, if I'm thinking about arrays of arrays, to be every single column. Every single, no, that's y, x is column, right? And then the y is every single row. Okay. So I'm going to do that. So I'm going to make a new array of columns. And then I am going to say for let I equal 0, I is less than that array dot length, I plus plus. Make a array index I is a new array of rows. Again, I know there are all sorts of shorter and fancier automatic functions for generating and configuring arrays like fill and map and reduce and all that kind of stuff, even more. So I'm going to do this, and then I am going to, what I want to do here now is I also want to fill them with, I guess I could fill it with values down here. So maybe I won't, maybe I'll actually just do that. So this is going to make me an empty 2D array with nothing in it. And then I think what I want is, I probably want to have these global variables. I know this is a little bit goofy that I'm doing this. And then what I'm going to do, I could make then I'm going to say let I equal 0. I is less than columns, I plus plus. And then I'm going to do j is less than 0, j is less than rows. I'm going to do a nested loop so that I can say grid I j equals floor random 2. This is going to give me a nested loop. This is a nested loop. So I make the sort of like 2D array structure that's empty, and then I iterate over every single column and every single row, and I fill each one with a random number, 0 or 1. And now I'm going to run this, and I'm going to go to my code. Ooh, okay, cannot read property 0 of undefined. Well, you know what would be nice? If I actually return that array. So that I make 2D a function array, it's making this array, it's also got to return it so that I can get it back here. And then now if I look at grid, I'm going to see it's an array of arrays. And I forgot, there's this wonderful thing you can do, like console.table grid, which shows me, now I can see it here. So we can see this is that two-dimensional array. That's what it looks like. It's a two-dimensional array with rows and columns filled with zeros and ones. So step 1 is finished. Now what I need to do is I need some mechanism to every frame of animation iterate over every single spot and set a new spot. Actually, you know what I should do first? I need to render this thing. I want to be able to see it as a grid of red and blue squares, or black and white squares, or zeros and ones on the screen. There's any number of ways you could render this. I'm going to do it in the traditional way of a grid. The square, the cell of the grid is black if the value of 0, is white if the value of 1, or vice versa. Okay, so let's come back to here. No. So what I want to do is I'm going to now go to Draw. And I'm going to create a canvas. Now, I'm also going to do something to make my life a little bit simpler right now. I am going to make the canvas a square. I'm going to make it 400 by 400. And I'm going to have, I'm going to be using this. Oh, I'm in the wrong place. Sorry, everybody. Let me come back. Thank you for camera. Yeah, don't worry, everybody. I know I'm in the wrong place. I just have to go back. What did I just do? Take this out. I don't think I had the draw function there. Okay. I don't remember what I was saying, but it'll get edited somehow. Okay, what I want to do now is I'm going to add a draw function. And I'm going to be using this loop over and over again. I'm going to add this loop, right? Because I'm always going to, anytime I want to look at everything, I'm going to go through all the columns and all the rows. It's been pointed out in the chat that there are some JavaScript libraries and packages that manage grid systems and neighbors for you. It would be great to use those. I'm going to just do it all without that right now, just to kind of figure it out. I'm going to say background 0. And I'm going to create a canvas. I think to make my life easier for the moment, I'm going to make the canvas also a square. And then what I need to do is I want to draw a rectangle, add an X and a Y with some width and height. And they're going to be squares, so some width and width. And that value is going to be the width of the I should probably calculate the number of columns and rows. Here's the thing. I'm going to redo the way that I'm doing this. So I'm not going to actually have a fixed number of columns and rows. Timeout. Edit point, Mathieu. Sorry. Just have to. This cold is a pain. Not late to big screens yet, am I? If it's 5:45, I really have to go. I mean, 5:30, I really should go. I'm still live streaming, right? Okay. Okay, I'm not going to set out the columns and rows. I'm actually going to do a scale, or I'm going to just actually have a variable called resolution. And I'm going to say that's 10 or 40. I'm going to say that's 40, so that'll be 10 by 10. And what I'm going to do is I'm going to say columns equals the width of the canvas divided by resolution. Rows equals the height of the canvas divided by resolution. This way I can kind of dynamically, you'll see I can dynamically make a 2D array based on how big I want the squares to be. So the columns and rows are being calculated based on how big I want the squares to be and the canvas size. And then I have that global variable resolution, which is probably too long of a name, which I can just use down here. And now x equals I times resolution, and y equals j times resolution. And I'm going to now say if grid I j equals 1, fill 255. And you know what? Since I made the background 0, I can actually, in this case, I can just draw white rectangles only for the values of 1. So let's see. I probably got something wrong here, but let's try to run this. No, I didn't. So we can see, there we go. Now there's some goofiness, oh, it's sort of like my math is a little off, and what's this weird nonsense over here? Flickering. I kind of feel the need to fix that. And the other thing that I can do this is going to help is if I make this 600 by 400 and I make this 20, right? It still works. And now this is driving me crazy. I think what I want to do is there's a sort of issue with the stroke. So do I want to also say stroke 255? Yeah, there we go. That'll do for now. Sorry, oops. There's a little bit of an issue with how this looks due to the stroke. So I could also say stroke 255. and then I'm getting something like this. But I don't know, design-wise, I'm not going to worry about that too much. Actually, I kind of like being able to see the grid. So let me actually put in stroke 0, and then I'm going to do something kind of goofy, which is, I think if I say just draw all the rectangles like 1 pixel less, whoops, I think I'm going to get the look that I want. Yeah. So whatever, there's countless ways I could deal with this, but now I have the grid, I have all the cells. So now it's up to me to simply implement these rules. I need to, for every single cell, count the number of live neighbors, look at its own state, and have these rules play out. Here's the thing. This is really important. While I'm checking each cell, I check this cell first, let's say. I cannot change its value and then go on and check the next cell, because the next cell's new state should not be dependent on this cell's new state, but its previous state. And if I've changed its state, I've lost its old state. So this is where what I actually need is I need two two-dimensional arrays. One is the sort of old one, and one is the new one. Now, probably the simplest thing for me to do is just make a new one every frame. That's sort of like, in some ways, a bad idea in terms of memory management. And if you look at my processing example that I referenced at the beginning of this video, what I actually do in that example is I just have 2 different arrays. I have an old one and then I have a new one. Then the new one is then the old one and I write the new one over here. I just keep swapping them. So I could maybe add that in at some point during this video. But for right now, at the beginning of draw, I'm just always going to make a new generation. So what I can do here at the beginning of draw is say, I can say, I'm going to call it next. Oh, I'm in the wrong, did it again. At the beginning, what I could do here, why does that keep happening when I press the button to change the camera? At the beginning of draw, I can say let next for next generation equal make 2D array, columns and rows. Okay. Now I'm going to leave this here for the rendering, and what I'm actually going to do is at the end, what I'm going to do is I'm going to say, I guess it doesn't really matter. Do I want to like render first? This is kind of like a philosophical, deep philosophical question. Do I want to compute and then render, or render and then compute? Kind of could matter in some situations. In this situation, it doesn't really matter. But the reason why is like I'm never going to see the first generation, because what I want to do is say grid equals next. So basically, the algorithm here is compute next based on grid, because draw is looping. So I want to compute the next generation based on the grid, make grid that, render, and then compute the next generation based on grid, make grid that, render. So I don't know, now it's bothering me. I'm going to do this. I'm going to do this after. So at least I draw the first one, and I'm going to do some computation for the next frame. Okay. So now, what do I need to do once again? Loop through all of these. Loop through all of these. Now what I need to do is count live neighbors. I need to count the number of live neighbors, the neighbors that have 1. So I could do a kind of internal loop here, and that would probably be a smart thing to do.Maybe I will do that, where basically what I do is I say I have a certain, I'm at a certain cell. Let me look at the cells between -1 and 1 and -1 and 1 offset from where I am. I could also just do something really silly, like, let me do the really silly thing first. I could say let sum equal 0. Then I could say sum plus equal grid I minus 1 j. That would be the neighbor to the, so, right? If this is I comma j, I minus 1 comma j is there, I minus 1 j minus 1, I j minus 1, that sort of thing. So if I'm thinking about this, I might like I could like manually put in all the neighbors. Just like add them all up. Like, this is like, I'm kind of going around the horn here, right? plus I plus 1, j plus 1. Sometimes I like doing ridiculous things like this just to figure this stuff out. Now I got to go I minus 1, j plus 1, and then what's the last one? I minus 1, j. This should be 8 neighbors. And right? This is 8 neighbors. 1, 2, 3, 4. Oh, wait. 1, 2, 3, 4, 5, 6, 7. What did I forget? I minus 1, j minus 1. I, j minus 1. I plus 1, j minus 1. I forgot to do that whole top row. And then I plus 1, j. I plus 1, j plus 1, I. Yeah, so this should now be 8. 1, 2, 3, 4, 1, 2, 3, 4. Okay, I kind of hate that I did this. You're all like throwing your tomatoes at your television screen because of course you're all watching this on a television screen. So this is the idea. I need to add up all those neighbors. Let's do this in a loop. So another way I could do it is I could say, I have a better idea. Let's neighbors, I have a better idea. Let's write a function to do this. Neighbors equals count. I'm going to give it the grid, and I'm going to give it the I and the j. So I'm going to write a function. I'll put it all the way at the bottom of my code that receives, I'm going to call it count neighbors, let's call it. And it's going to receive some 2D array, and it's going to receive an x and a y location. And then what I'm going to do is I'm going to say, I equals -1, I is less than 2, I plus plus. Then, so I'm going to do a little nested loop using I and j around that spot. And I'm going to say let sum equals 0, and then I'm going to say sum plus equals grid I, j. However, here's a problem. I don't want to count myself as a neighbor. So there's a few different ways I could do this, but it's a little bit silly. I'm just going to like subtract it at the end. Like I'll just subtract it out. I could have like put an if statement here, like ignore it if I equals x and j equals x, but I'm just going to subtract it out at the end. And then I'm going to return that sum. So this is, you could see like a couple different ways of doing this right now. This is one way to kind of do this. What this is doing is it's saying, let me do a little loop around here. -1, 0, +1, -1, 0, +1. So let me check this, 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 and then subtract this out because I don't really want to count that one. Okay, so now I should be able to, I'm going to just delete this. I've now counted all of the neighbors. I've got a big problem. What do I do with the fact that if I'm on the edge, there's no neighbor to the left? If I'm on the bottom, there's no neighbor below. If I'm on the top, there's no neighbor to the above. If I'm on the right, there's no neighbor. If I'm on the edge, there's no neighbor to the right. So what I could do, there's a bunch of things I could do. I could consider this like an infinite wraparound world where like this neighbor to the right is this neighbor to the left is this. There's other ways that I could approach it. What I'm going to do is I'm going to leave the edges as fixed values and just not bother to check them. So what I'm going to do here is I am going to, I wanted to do like, I was going to do this loop like this. You know what? Let's do the wraparound. Do I dare? No, let's do it the simple way first. I was like, let me just add the wraparound code, because I could add the wraparound code here. But maybe I'll leave that as an exercise or do that later. So the issue is, you know what I really want? I think then the problem is if I change this loop, so I have to treat the edges differently. Oh, so much heartache here. But I can say what I'm going to do here is I'm going to say, oh, this is the drawing. Whoa. Oh, right, this is the computation. So I'm going to say if I equals 0 or I equals columns minus 1, or j equals 0 or j equals rows minus 1. This is like all of the edges. I'm just going to treat them differently. I'm going to say next ij equals grid ij. So I'm just going to keep the same values from before. This is not a great solution, but it's a quick one that I can do right now. So if I'm on an edge, I'm just going to use the same value. Because now what I can do is say, look at this. My state is grid ij. Now it's time for me to implement those rules, right? Okay, if my state is 0 and 3 neighbors are alive, change my state to 1. If state equals 0 and neighbors equals 0, then next ij equals 1. Okay? That's rule number 1. If not 0, equals 3. Okay, now what else? If I'm alive and less than 2 or greater than 3 are alive, then change my state to 0. Else, if my state is 1 and neighbors is less than 2 or neighbors is greater than 3, and I probably should put a little parentheses around that one. And again, I'm sure there are like some nicer ways I could write this in a more concise way, but you can see this is the rule, right? If I'm alive and I have less than 2 or greater than 3 neighbors, then the new state is 0. In all other cases, the next state is just the current state. Okay? So, and this makes me want to put this up here at the top so that I can also just use this here. So that's the state, right? The state, this is the current state. If I'm an edge, just ignore me. I'm the same state. If I'm not an edge, count all the neighbors, check if I should change my state or say the same. I'm seeing in the chat there's a typo at neighbors in the first if. Thank you. Neighbors. Okay. What's the chance I've actually finished this? So there we go. I think I have mostly all the code for it. Okay, count is not defined. Sketch.js line 55. Oh, right, because I called it count neighbors, which is a better name for the function than count. Let's try that. Cannot read property -1 of undefined at count neighbors. So what is undefined? Oh, no. Look at this. This is a big mistake, right? What was I doing here? This loop, right? This loop which goes, which is basically a loop for like a little subsection, right? If this is x and y, right, I is an offset -1 to +1. J is an offset -1 to +1. The cells I'm looking at are not ij, but x plus I and y plus j, because I'm just looking relative to where that xy point is. So that was a big mistake here. This should be x plus I, y plus j. Oh, so close. Count neighbors at draw, sketchline 55. Okay, ooh, sketchline 55. Count neighbors, wait. Cannot read property -1 of undefined. What's undefined? Grid? Neighbors? Okay, hold on. Let's look at some stuff here. Okay, grid. Oh, so hold on. Count neighbors. Let's just try grid 10, 10. Okay, so that works. That cell has 3 live neighbors. So I must be by accident looking at an edge, right? I must be looking at an edge by accident. Oh, not -1. No, yeah, -1. Or if j is 0. Oh, look at this. I just keep going anyway. So this, I need to break out of the loop. So this is really like, I'm done. Leave the loop. or continue or something. I don't know. I'm just gonna put an else in here, as much as I hate that. So, because I shouldn't be, I'm basically doing the edges or the neighbors. Boy, this will be much nicer if I just, in this function, add some code to deal with wraparound, which is not gonna be that hard to do. But now I should be good. There we go, the game of life. Now it looks weird because the edges aren't ever changing, but this is actually now the game of life working. I really got to implement this wraparound thing. So let's do that now. Let's fix it so that the edges consider the other sides as neighbors. So how do I do that? Well, one way to do that is with something called modulus. This is great. And I can refer you to Golan Levin's guest tutorial video on modulus, which was made as part of this channel, so I will link to that. But basically, I think what I want to do here, I need to, is basically, what I'm saying here is if I have 10 columns, 0 through 9, and I'm always looking for the neighbor plus 1, right? So 0 plus 1 is 1, 1 plus 1 is 2, et cetera, et cetera, et cetera. 9 plus 1 is 10, but I want the neighbor to be 0. Well, guess what? 9 plus 1 modulus 10 equals 0, because modulus is the operator that gives you the remainder of division. 10 divided by 10 is 1 remainder 0. So I encourage you to watch that modulus video if you're not familiar with modulus. So this will actually work almost, getting closer, if I say, I'm going to just say, like, I'm going to have a new, I need like a new variable name for x plus I. I guess I could say column. I don't like column, and I'm going to say x plus I modulus columns, and row equals y plus j modulus rows. So this gets me close. It doesn't get me all the way there, but it gets me close. So now I'm adding it up like this. And I'm gonna get rid of this whole edges thing, because no longer, okay, so I'm gonna get this done. Now I'm gonna have an error here, right? I'm still getting like an out of bounds error because I'm going to -1. Why? Because what if in the case of I equal -1? So what is, if I is 0, right? So let me come to the console here. 10 modulus 10 is 0. But let's say I'm looking for the left neighbors. So I'm going through -1. -1 modulus 10 is -1. But I need that to be 9. I need -1 to be 9. Well, guess what? If I actually just add the number of columns to everything, right? If I'm actually working with the numbers, instead of the numbers 0 through 9, the numbers 10 through 19, right? 10 minus 1 is 9. Modulus 10 is 9. So the formula is -1 is -1 plus the number of columns modulus the number of columns. Oh, but it's not 10. There's different numbers in my system. But let me be clear about this. What I want to do is I always want to take the value I, add the number of columns to it, and then modulus the number of columns. And what this is actually doing, we can think about this for every possible location. 10, 11, 12, 13, 14, 15. I'm going to go all the way up to 19. 10. Well, because I is 0. 0, 1. 10, this is the result of I plus columns. 10 x plus I plus columns, right? So if x is on the edge 0, and I say -1, whoa, did I make this confusing? And I'm not even on the right, thank God. Thank God I didn't switch it. Because I totally just like, that explanation was horrible. So thank goodness I didn't switch the camera. I'm so glad I didn't switch the camera. Hold on, let me back up here. Can anybody screenshot for me what the whiteboard looked like a few seconds ago? So I can erase it back to that point? And it's half past. No, but I'm really close to done. We won't be doing the 3D. That's for sure. Wait, how long did I do that for? I don't remember where I was. Is anyone in the patron group capable of looking at, so this is what it is right now, but the last time that I was there, what was it? I'm waiting to see if, because what was I don't remember how much I did. Oh wait, thank you. Okay, great. So it wasn't as much. Okay, I don't have to go back that far. I was just like kind of doing it again. So hold on. I'm going to look at this. No, that's what it is right now. That's what it is right now. I don't want this. TMC gave you what it is right now. I want what it was, right? Unless I didn't add very much. No, but this was all my crazy explanation. So I need what it was before. So I know what to erase. Thank you for people in the, I can't really see in the YouTube chat, unfortunately, easily. I really appreciate that, Parsley, though. Parsley just posted in the YouTube chat if someone can post that into the Slack channel as an image. Great, thank you. Okay, this is good. So I'm looking at this image right now, and all of this stuff. Anybody know the last thing? All of this stuff is gone. All right, so this is looking exactly the same. Excellent, thank you. So the problem is I don't remember what I was saying. All right, whoops. All right, well, I'm just going to give this a try. Though this is what I was saying last here. Okay. So let's try to confirm this again. Okay, the idea is that I have an x and a y point. So that point might be, let's say if it's on an edge, for example, might be like 0, comma, it's on the left edge, might be something like 0, comma, whatever the y is. 10, 5. So this is the x value. And I want to take x plus I plus the number of columns modulus the number of columns. I said this is going to be simple, but it's really kind of like a crazy thing to do. But you might write this out and practice it a bit on your own. It will make sense to you eventually. So when this is going to work, basically, let's say I is going to be the values -1, 0, and 1, right? X is going to be the values 0 through 9 if I'm thinking about all the possible columns. So let's just take 0 and -1, for example. 0 minus 1 plus, and in this case I have 10 columns, plus 10 modulus 10 is actually 9 modulus 10, which equals 9. So 0, -1 to the left of it, that wraps it around to get the neighbor on the right. Right? Doesn't work for just any arbitrary thing in the middle. Like if I take I to be 3, sorry, if I take x to be 3, 3 minus 1 plus 10 modulus 10. Well, see how this 10 and 10, it kind of cancels itself out. Can you see that? Am I off the whiteboard? I'm close to being off the whiteboard. That equals 2, right? Because this is 12 modulus 10 is 2. So this actually works. And then what if I'm on the edge, if I'm at like 9, right? If x is 9, 9 plus 1 is 10, plus the number of columns is 10 is 20, modulus columns, 20 divided by 10 is 2, remainder 0, 0. So 9 to the right gets its neighbor 0. So this is kind of goofy. It like shifts everything over so it can kind of look across the edges. So this is going to work. You can believe me or not believe me, but it's going to work. and I'm going to put this in. So now what I want is x plus I plus columns, modulus columns, y plus j plus rows, modulus rows. Add those all up, and the game of life. Thank you. Thank you for watching this coding challenge. Thank you, thank you. So let's try doing a couple things just to get a little further here. I don't know. No, I'm not going to do, you do all the next stuff. I'm just curious, like, let me make the resolution 10, so we can see that's with it 10. So you can see it's running pretty fast in the browser. I have a pretty slow, low resolution. So here's what you should do now. I'm going to stop. This is a perfect opportunity for people watching this video to make some variations. Some things you can think about. Well, one thing is, what if you make each one of these cells an object? So its state might not actually just be, it can keep track of more than just its state 0 or 1. It could keep track of whether it's changed state or stayed the same or how long it stayed the same. What if you visualize those? What if you visualize with different colors based on the history of the system? What if you allow a user to draw with the mouse and set cells on? What if you look up some of these special repeating patterns that you can create certain kinds of patterns? What if you, you're going to think of more, and what if you did the edges in a different way? What if you used the floating point numbers instead of zeros and ones and did like an average or something? There are so many ways you can create a system lowering the resolution. What if you didn't draw squares but circles, used images? How can you visualize this system? How can you change the rules, or how can you visualize the system in a different way to create a piece of art or for some other purpose? I look forward to you. Share what you make in the comments. There'll be the code link from here and a README where you can submit your versions, and I'll come back in a future live stream. I'll share some of the community-made versions. Run this again. There's one other thing, but I do think that making cell objects is a path, right? Right now I just have, and you should probably do the swapping thing. Like, maybe that's one other thing you could do is like, don't make a new 2D array every time. But what I'm thinking about here is what if instead of each one of these being a random value, you said something like new cell I comma j. And this cell object can animate, it can move around, the cells could move, they could grow, they could shrink, they could keep track of their history. There's so many possibilities there if you make an object for the cell. Okay, thanks for watching. I hope you enjoyed this coding challenge and you share with me what you make. Goodbye. All right. 5:40. Okay, everybody, thank you very much. Oh, I got to read some random numbers. I don't remember where I was. Maybe I won't read random numbers today. I'm happy to take some last questions. I'm pretty good for about 3 or 4 more minutes. So I'm going to, if people are asking where do I have to leave, well, one thing is I've been here for, I don't know, almost 3 hours now. Yeah, almost 3 hours now. 3 hours now. So that's one reason why I have to leave. But I'm also going to an event tonight called The Big Screen Show. Doors open at 6 o'clock, which is 20 minutes from now. It will definitely take me at least 20 minutes. I can walk there, but it's probably like a half an hour walk. Maybe I'll take the subway. But if you're there, I'm going to try to remember to put some stickers in my pocket. And then if you're there, say hi to me, say you were watching the live stream, etc. I've only been here for 2 hours, Simon. No, I started at 2:30 p.m. Eastern. It's 5:39. It's 5:40 Eastern now. It's been 3 hours. So I will be back next week. I'm hoping to actually do 3 live streams next week, if you can believe it. It's important to me, especially for the folks that are supporting me on Patreon, to try to do what I'm committed to for that support is 4 live streams per month. And I think I missed 1 in November and I missed 1 in December. So hopefully doing a couple extra next week will catch me up. So, DFLO Sounds says that's a 4-minute walk right now. So technically you're supposed to RSVP. Maybe you could just, I think it's probably fine if you go anyway. Just name drop me. Say I said you could go. DFLO Sounds, if you actually do show up, try to find me and say hello. Okay, oops. All right, so thanks everyone for watching today. I am so glad to be back. I feel kind of good about, I feel like that coding challenge kind of went well. Does anybody have an estimate how long that was? Like, do you think that was like a half an hour challenge? Like, think about the editing a little bit. 20 minutes? I don't know. Okay, thank you everybody for watching. And I'm just checking here. All right. Oh, wonderful, Overmind. That's wonderful if you want to translate all the videos to Portuguese. Send me a message on Twitter, @Schiffman, if you have a Twitter account. So you can, because when I get submissions on YouTube, it doesn't tell me who submitted them. 25 minutes probably. Okay, that's pretty good. Music video, play the coding challenge video. I don't know what that is. Oh, coming in January 2018. Some videos on machine learning. Thank you, everybody. I'm going to click stop streaming now.